Hi everyone. Thank you for first of all coming in the early morning, that too on weekends. So yeah, we will start. So before starting, I would like to know how many of you are actually working in data engineering space. Can you raise your hand? Okay, and how many in the software? Okay, few. How many of you are actually aware about the open table formats like Apache Iceberg, Hoodie, or Delta Lake? Cool. And how many of you have actually worked on real-time streaming pipeline or any project which involve real-time streaming? Cool. Yeah, this is good number. So our agenda for today is the real-time and also the Lakehouse. And I am from E6 Data, so I am with my team. So I will be also presenting my thoughts on Iceberg catalogs and what are the emerging catalogs in the recent times and how it is actually changing the space. And the people from Confluent and AWS, yeah, Ankit and Devanshu from Confluent, they will be sharing their thoughts on real-time use case of data streaming platform. How many of you are actually know about Confluent, and how many actually like like don't like using Jira, Atlassian, and all those things? No one. Okay, so and Ravi from AWS, I think some of you might be knowing Ravi. So he will be talking about simplifying data and AI with Amazon SageMaker. And yeah, and in the last, I will be sharing my thoughts. I've recently written one blog also. If any of you have you written, read that blog? I don't think so. Okay, we will share that blog link in the end. So I will be sharing my thoughts on emerging catalog and streaming ingest problems that we see in open table format like Apache Iceberg. And if you have observed the space in a recent times, at least in data engineering space, I have not seen that much of, I should not say noise, but that much of talk in last 5 to 6 year, near to 6 year, until unless AWS announced their S3 tables and the Iceberg, like the tabular was acquired by Databricks. So do you know about these two incident? Like, are you observing this that AWS has recently released something called S3 table? How many of you actually know about S3 tables? Cool. So if you follow Reddit and if you follow LinkedIn, mostly Reddit, so you might have seen so much of discussions going on that this is good, this is bad, why to do compactions. And when Tabular got acquired by Databricks, if you have heard the news, it's more than billions. And they are the very small teams near to 35 members who were actually behind the Apache Iceberg. And now every other data platform that you see in the world, they are actually trying to have either their first class citizen or second class citizen as Apache Iceberg. For example, if you see, there was recent things by Starburst, like this Trino company, who is trying to load the data into Apache Iceberg. Then there is one product uh, called this Tableflow, okay, where the people are actually trying to load into Apache Iceberg. If you have heard about the Rust-based streaming engines, something like Rising Wave, their first-class citizen nowadays is Apache Iceberg. In S3 tables also has the Apache Iceberg. They are the managed tables. Under the hood, they are actually using Apache Iceberg. Databricks has recently announced that they are going into GA for their Unity catalog, which will support Apache Iceberg. So a lot of things has actually happened in last couple of years, and I'm near to 6.5 years of experience in data engineering, and I have not seen that much of talk going on. Previously, it was all good. I think those who have seen the transition from Hadoop to data lake world, they might have seen this type of lot of discussion going on when people might be moving from MapReduce to Spark. But when I started, most of my work was actually in Spark, and after that, I have not seen lot of invention happening, at least which gather a lot of people in the market. And I find Apache Iceberg and real time, the push to real time streaming is actually changing the world, and there's lot of talks going on for these particular two things. So in this talk, we will actually try to understand these two things, and we will actually try to understand. I think Ankit and Devanshu, I think you people are also going to talk about Tableflow, right? Okay. So yeah, so we will try to understand their strategy, what they are trying to do, and we will try to take it forward. Will Vignesh, do you like to explain what we actually?
Thank you, Ankur. So I just wanted to quickly introduce who we are, E6 Data, what we do, and I think a lot of familiar faces, so you guys might have already heard this spiel before, but let me just sort of quickly jump in. We are a data infrastructure software company based out of Bangalore. We build data lakehouse compute engines. Our entire premise is that based on modern architectures, there's a lot of efficiency to be gained out of re-engineering how distributed compute engines are built. We're, like I said, Lakehouse native, so we don't have any other sort of underlying model that we support at this point. Um, and we are currently a query engine for the most part. We will also be working on, as you'll see today, and I think in the previous talk, Arvind and others had sort of spoken about it. We're also working on real-time ingestion. We're also working on transform use cases and on the NL to SQL agentic sort of workflow use cases as well. The real premise, the real value prop that we offer is given a Lakehouse native architecture. Our efficiency is somewhere in the range of 5 to 10x in terms of query performance. And because we are that much more performant while running a query, SQL query, we tend to take that much lesser time on compute. We occupy that much lesser compute resources. Because of occupying lesser resources for lesser time, we can fairly easily guarantee 40 to 50% cost reductions on existing data platforms. So that's our entire business, and that's how most of our customers work with us to say, hey, I'm currently on X engine using a lakehouse. I'm worried about my costs. What can you guys do? We go in and help them sort of re-architect a picture that looks like this, right? Where we say, you have a lakehouse architecture that's fairly straightforward. All of you guys would understand this very clearly, right? So coming from the left, you've got multiple sources that sort of come through an ingestion workflow. It lands into a particular lakehouse. Could be Delta, could be Iceberg, could be raw Parquet, could be some on Hive, could be some other catalog like Unity, whatever. Like we support all of that stuff, right? And then from there, you have engines like E6 that can either do transformation jobs for medallion architectures, or if you have final tables ready for querying, can do actual querying use cases. This connects to downstream BI reporting use cases, a bunch of different things that you could potentially do to run SQL queries from. Right? The core of this is, given most of you guys would be from large enterprises, well-established digital natives, it doesn't make sense for a startup like us to come in and say, hey, listen, we will do all this magic, we will reduce your cost by 50, 60%, we will make your queries faster, but you have to change A, B, C, D, different things in your existing architecture. That's too much friction, it's a no-starter, right? So instead, what the approach we take is we will integrate with your architecture, with your particular stack. So irrespective of what table format you have, irrespective of the fact that you have single cloud, multi-cloud, irrespective of whether you're on-prem, on-cloud, whether you want hybrid of on-prem and on-cloud, we support all the variety of combinations that you can possibly sort of have. Right? We have customers who are using us for cross lakehouse querying, so which is Iceberg and Delta at the same time. We have customers who are using on-prem and cloud. We have customers who are using multi-cloud. So all of those use cases are supported, including being governance aware so that we're sensitive to sensitive information on your side. We adhere to what governance policies you already have defined in tools like Ranger, Unity Catalog, etc. So it's a lot of interesting integrations built around all of this. And one of the core things that we're working on now, and our, the head of the project here, Arvind, is at the back. So the idea here is, let's try to get as fast streaming ingestion as possible from a Kafka source into a lakehouse for customer use cases, right? So now the picture basically sort of says event to queryable data in seconds. Right? Now, this is queryable data in Parquet. It could as well be queryable data in Iceberg, on top of which you can run compaction, optimization jobs, etc., to keep the lakehouse intact, but event to queryable data in seconds. And now, this is at scale. We're working with observability providers who have roughly 150 to 200 million events sort of being generated every second, right? So it's a lot of data that sort of comes in. And that is what we're talking about in terms of being able to write effectively with latencies of up to a second, up to a couple of seconds, in order to get that data to be a queryable, in a queryable state. Again, the fundamental premise of this holds multi-cloud, multi-table format, multi-vendor sort of integrated approach. So we don't have a unique tie-in on any of this. Nothing here is sort of proprietary other than the engine itself. I don't know if this, no, this can't be playable. This is a PDF. So I think that was meant to be playable, but I've converted this to a PDF very smartly. So I'll show you this video offline. But this is a view of our NL to SQL layer that we're building. NL to SQL in and of itself is, okay, yeah, a lot of people have NL to SQL, but the catch is the way, for many reasons, other vendors have implemented NL to SQL within a particular SQL interface. There are a lot of restrictions in terms of the number of catalogs that you can query, the number of tables that you can query, largely to maintain the scale of what you're actually deploying. We're trying to get away with all of that. We're trying to say, I don't care if you're querying 10 tables or 10,000 tables. I don't care if you're querying 2 catalogs or 2,000 catalogs. This will still be accurate. We will guarantee a certain level of accuracy in terms of your NL to SQL conversion. The real catch here, though, is in addition to the NL SQL stuff, is we're sort of architecting it in a way where different agentic workflows can potentially tie into this. So we are not necessarily doing much on the agentic side, as in building the agents, but whoever wants to build these agents that can then connect to the lakehouse to be able to query it, either to sort of check for availability of data or to check for governance rules or to check for catalog permissions, whatever. All of those different layers we're opening up as a part of this project. So future agentic platforms can sort of connect in. We already have an MCP server that we have built that we can throw on top of your lakehouse via E6. So that's sort of the future that we're building this entire thing for. Happy to answer any questions on all of these things as we sort of go through customer references. And this is the most important slide I wanted to put up. We're hiring a lot. So if you know anyone across any of these roles, please do let us know, ask them to reach out. Our email ID is just hello@e6data.com. We are very competitive in terms of our sort of CTC ranges. And we also have a, the way I like to explain it is we have a dumbbell-shaped organization where there's a huge spike in the younger work experience and a huge spike in the older work experience. I'm very clearly on the older work experience. So there's very little middle management, there's very little layering. Most of the organization ends up working on very, including interns, end up working on very critical sort of projects. For example, Ankur owns a very crucial piece of technology for us, along with a bunch of interns, where he's building what we call the transpiler layer, which has the potential to radically change how customers think of SQL engine migration. His transpiler will effectively take SQL queries from a dialect and convert it to our dialect, potentially a dialect to any dialect in the future, but we're focusing on our dialect as the destination first. This cuts down 6 to 8 months of migration work that customers go through, going from, let's say, a Snowflake to Databricks, where literally 6 months of that work is just SQL migration. We can now do that in days, right, because of the transpiler. So, and that entire team was staffed by interns. So there's a lot of ownership and a lot of drive that happens in the company. Anything else that you want me to highlight? Cool, excellent. So then over to the guys from Confluent. You have a question, yes? Okay, we get this question every time. Is anyone here from the previous times where we've answered and remembers why we're called E6 Data? You were there the last time. You should remember. No? No, behind you. No. Anyway, so our objective is to be 1,000,000 times better than anyone else. 1,000,000 in scientific notation is 1 E6, hence E6 data. That's the idea. Yeah, cool. All right, over to you, Ankur.
Yeah, Ankit and Divanshu. Yeah, so they will be explaining about real-time use case of data streaming platforms, and one of the recently launched product, Tableflow, which I have actually used. So I have a lot of questions for you guys. Yeah. Over to you.
Sure. Hello, everyone. Myself, Ankit. Okay, let's have the slides. 1 second. Yeah, myself, Ankit. I'm a senior software engineer at Confluent. I've been there. It's been almost 3.5 years at Confluent. So I'm part of a team called Cloud Audit Log. So basically, we are responsible for managing entire stack of Confluent Audit Log, which is a security feature which is provided to the customers, right? And we encounter a similar problem what we all are talking about, right? A really large data size, and that is where I think I'm going to talk about some insight on what help us, and then basically the table flow, right? And I have Devanshu with me. He joined as an intern recently, and he's a software engineer. So he was the one who was able to kind of do the table flow integration. So that gives like how simple it is, right, for us to be able to kind of onboard, right, and then ease of use. Okay, going next. The overall agenda is going to be looking at real-time architecture, right? And what is a typical data streaming architecture look like? Deep dive into Confluent Audit Log, how we are trying to achieve this, right? Solving this problem for us. And then we'll take a stab at long-term archival solutions like Apache Iceberg, how this is relevant, and then finally Tableflow. This is what I think it's an implementation of Iceberg tables. So yeah, in the end Q&A. Okay. So yeah, overall, in terms of what is real-time data streaming, right? It may be like you have an influx of events coming in, which are processed immediately, and there is no delay, right? So it contrasts with batch processing, where early in the days where you used to have like a batches that used to run every day or every hour, but now the insight is immediate. As soon as data is arrived, you are able to process it, and then basically it is put to the use, right? And then some of the application may be that, okay, someone use your credit card or something, you get an immediate alert that, okay, someone has spent that much amount, and then even the monitoring, I think this is one of the biggest use case. Like all of us, like at least I'm a software engineer, and something goes in the production wrong, and you get a paging alert, right? That, okay, this service is not working out. So that gives you a real time kind of an event manager system that gives you some kind of like real time actions. Okay, coming to typical use cases, as we talk about, there could be use cases like IoT devices, observability, I think one of the biggest use case, banking, telecom, video, gaming, streaming. So these are typical use cases that I think we try to solve. And in terms of stream processing or streaming requirement, probably we will look at, okay, how we can achieve low latencies, high throughput, scalability, fault tolerance, durability, and some kind of consistency and ordering. So these are, I think, all the terms with respect to distributed system. And when I talk about, okay, I want to kind of process some streaming capability, I want something like, okay, I should be able to aggregate data stream, right? Into a fashion where you may have data coming from multiple data sources, and you are able to kind of aggregate it and then give some insight or generate another stream for other applications to use, right? So that's like one of the examples of you kind of using some kind of stream processing capability. Okay, so looking at high-level architecture. So on the left-hand side, you may have like a lot of producers who are producing this data, and then like from 10 years from now, we can say that data without governance was okay, but till the point we want data to be governed, and there has to be like a schema or some kind of a set of rules which says that this is your data, and this is how it should be used, right? So data governance has become one of the critical requirement, where data has to be in a specific format, and then you use something like Kafka or any distributed messaging queue to be able to stream your data, right? That gives you all the the asset requirements, right? You are able to produce data, consume, consistency, ordering, a lot of other things, right? And then on top of a distributed queue, you would want to process your data, right? So this may be something like a K-stream, or maybe Flink, or some other streaming engine that is able to real-time process your data and generate another data stream on top of it, right? And then finally, you would put the use of data, right? Send it to some destination or to a data lake. That becomes one of the prominent use cases. Okay, coming to Confluent Cloud Audit Log. So I'll first talk about what audit logs are. So audit log is basically a user's interaction with Confluent Cloud. So when a user comes to Confluent Cloud, they may do certain operations, and we capture those interaction as these audit events. And then these events can be used later point in time to understand what happened in their cloud account, and they can get some insight. And this can be used in case of tracking abnormal behaviors, or probably creating some monitors or alert to be able to kind of handle any security risk. Okay, going next. A typical sample audit log. So basically, a typical audit log may look like, okay, there may be some detail which is which is the user and how the user, which action user did. In this case, user tried to sign in, and then which resource the action was taken on, what authentication it was used, and then probably some more detail like, okay, what was the client address or the IP from which the action happened, and there may be like a lot of other metadata that we can capture as part of audit logs. So this is more towards application side, and then we will move more to like a data streaming use case, how we solve this data streaming use case for our audit log, right? So in terms of problem statement, what we would say is that ability to collect logs across all domain, which means that Confluent typically have hundreds of microservices, and overall we may have around more than 100K of Kubernetes pod, right? And all of them are kind of serving one of our other customers' workload, right? So there may be a lot of traffic coming in from an external customer. The traffic may be data plane traffic. Someone is trying to produce data to Kafka, consume data to Kafka, and all of those actions generate audit logs, right? So we want to ensure that we capture all of those audit logs. So that means across all domain. It includes across multiple services, data plane, control plane. There may be cross-platform services as well. Any new service that comes up should be able to integrate quickly, right? Because someone is launching a new API, let's say public API, and they want to integrate with audit log, ensure that, okay, they have the data compatibility. So from a customer point of view, probably we would want to ensure that we are able to deliver these logs to customer. There's a data isolation. A customer is able to capture their own data and no one else's data, and then that is delivered in secure manner. And probably generate some kind of a real-time stream, right? So that they can have the potential benefit of some real-time monitoring and fraud detection on their data.
Guys, we are very much known for very interactive sessions. So if you have any kind of questions, feel free to ask. It's not like a time bounded, and I think my voice is loud enough. Am I audible? So what I'm saying, we are very much known for our interactive sessions. All the conferences that we have done till now in Bangalore or out of Bangalore, we like to have lot of discussion instead of one person's trying to explain us some things. So feel free to ask any questions, and let's make it more interactive instead of waiting for the end, because see this is going to be very highly technical session. So in the end you might not remember your question itself. So better to have a more interaction. We can skip some of the slides. I'm okay with that, but please feel free to ask as much questions, and let's have this as a discussion round, not like a one person is speaking. So yeah, yeah. If you have any questions till now, feel free to ask. Yeah.
Yeah.
Right. So you're talking about audit log, right? There are other things we used to maintain what it call all stages of data from where it came and what got transformed and all that. So is it something different, or it's the same within audit log itself? It's get captured.
So I would say it's a superset, right? So any action that happen on customer data, right? So
Right. So
probably
in
the aim
nutshell,
is, yeah,
I'm referring data lineage versus audit log.
yeah.
Are you having different opinion, or it's the same?
Okay, it's not data lineage. Lineage is basically you have a flow of data where you kind of say where was what was the origination of data, and then in what are all subsystem it went through, and how it transformed, and it gives you like a complete picture of your data flow. So lineage would apply on any data pipeline, which can say what was the flow of data, right? A data pipeline may have like hundreds of services. So it can say that, okay, Uber, a user request like a ride, and how the request went through entire Uber subsystem. That gives you a data lineage. Where audit log is mostly like a security event, which gives you kind of a key security detail, right? Like which is to more with customer resources.
Okay. So it seems like just um, data change capture means what are the changes happening, or what just access control level logging means. Just I'm trying to make sense. What do you capture in audit logs?
Yeah. So uh, as you said, right? So it captures both, right? If someone has done some read operations on a customer resource, who did it, when he did it, what IP address, what principal was used, if someone has created a new resource or deleted a new resource, or if someone is producing to a Kafka topic or consuming from a Kafka topic, or any of the system, right, of that, like maybe like a UI, maybe CLI, maybe some REST API, or any public interaction of a customer with the cloud as a service, right, that would be captured as part of audit log.
Yeah, over here.
Yeah.
What is the objective? Why are you collecting these logs? What is the ultimate objective?
So ultimate objective is to be able to kind of cater to the key security requirement. So I'll talk on a hypothetical scenario, right? From a customer as well as we as Confluent level, right? So from a customer point of view, let's say you are on Confluent and you are running some workload. Tomorrow, an API key get leaked, and you want to, an API key got leaked, or some credentials got leaked. Now you want to know what are all things was done by using this API key. So you would be looking at these audit logs and understanding what are all resources this API key has touched, what are IPs was used to from what are all locations the actions were taken in, and there may be other scenarios where, yeah.
Okay, so when I meant objective, is that something that you are providing a benefit to the customer, or is that something that you as Confluent, as the provider, you are capturing to analyze the feature usage and improve your product? What is that ultimate objective?
I would say it's the first one. It is definitely we provide it to the customers because they want to understand, or like a lot of the security customers have, a lot of banking customer have this requirement of capturing audit logs, which is a standard feature. If you look at AWS, is audit trail. There's similarly there's Azure audit logs, which talks about similar things in a different data format, like which tells what is happening to a resource in cloud and how someone is interacting with this resource, right? So these are security events.
So is the customer's consent acquired before capturing these logs and moving them out of their premises, or or their infrastructure? I'm assuming you're probably doing that processing on the Confluent side, right?
Yeah, because customer is interacting with Confluent resources, right? So they may have, let's say, a Kafka cluster, which is running on Confluent Cloud. So we would be capturing customers' interaction, right, to that Kafka cluster, and then capture these audit logs, and then send these audit logs to customer, where they will archive it, and they can reuse it wherever they want in future for any incident, or if they want to do some analysis, there was some data leak, let's say 6 months ago, and they want to analyze it, these would be the audit logs they would look at.
The reason why I asked that is there is PII data. So if you're talking about, let's say, logs that capture the names of the topics, right? The names of the topics could be PII data for that particular customer, right? And it could be sensitive data. So that going out of the customer's network or infrastructure will be considered as infringement on the PII data.
Yeah, I think we are under data protection compliance. So there is always like a layers of data, right? So for an example, your credential secret would be at the top level, personal information would be at the second level, the resource or whatever resource which is owned by Confluent is what at audit log level is. An entire pipeline is basically like no one has access to this entire pipeline within Confluent, right? It is under protective domain of InfoSec, which is the entire security team of Confluent, who manage this entire data. And the access to this data is always kind of need for basis access, right? Anyway, like customer data, customer topics, all of that are stored in Confluent in some way or other, right? Let's say customer creates a topic or they want to kind of create a cluster, there would be some database table which would be storing this data, right? So it's not that we cannot store customer data, right? Because we provide it as a service, we are liable to store all such information. But again, the PII has multi-layer, I would say, multi-layer high to medium to low. So what we are at is that the access to this data is restricted, right? Nobody in Confluent can go ahead and say that, okay, I'm trying to access someone else's audit log or a customer's audit log until they have kind of a security clearance. That would become an incident.
Right. So I had few more questions, but then I'll probably let others also ask.
Yeah. So, excuse me. So far, we have discussed a lot about data lakes, right?
Right.
How far Confluent support data fabric and data mesh as such?
Yeah, I would say that the entire ecosystem is basically on Kafka, right? So there is like a lot of stream processing, stream engine, like which is happening. So the typical, I think what we are going to discuss is a very simplified use case, but then it 10 to 10x more wider, right? In terms of data mesh. Yeah, I won't say this is data mesh because like it's a single pipeline. We don't have a lot of other kind of use cases or other clients, but typically it's a large enough streaming use case for us to be able to kind of consider in a real life example.
Okay, so effective as such, right?
Right.
Thank you.
So here in the principal, what is the actual data you have in the principal? The second point.
Okay. So basically, it captures the user ID, right? So like a user, a user in Confluent, right? They may have a principal ID, or it may be like a sign-in user, or it may be like an API key, which is then attached to a service account. So it may be a service account, it may be an identity SSO ID, which is used for that action. So it would be one of these identity of the user who did the action.
That is your principal, or that is just a which block? Can you show me the block?
1 second. Yeah, so if you look at authentication info, principal is the acting principal who did the action, and like it's a complex structure. So it could be like a complex nesting of multiple kind of options, right? So in this case, it's an email address, and then the resource ID is a resource ID of the email address. In some cases, it may be an API key, right? And then the service account that is attached to that API key. In other cases, it may be an SSO ID, right? And then the user, federated user for that SSO.
If a user does a multiple action, then let's say he has multiple, let's say multiple group, part of SSO, part of federated, then how you combine those?
Yeah, so
In the principal terms.
Yeah, so basically it's internally we call it AUPM, which basically a user is attached to multiple kind of groups, right? So during authorization, so whenever at the auth layer, we try to kind of figure out which group was used to authenticate and authorize this request. So that would be present as part of your authorization info. Authentication info just talk about identity of the user, and there may be another section which is authorization info, which says which group or SSO federated identity was used to authorize this request. So there would be a separate block which is authorization info.
So every time the principal, whatever the block it is passing in every message, or it is just a one-time activity?
Um, I would say that
From the authentication or authorization log, you take those.
so there are different kinds of audit logs. So we support around 100 plus different audit logs with which is ranging for different use cases. So there are specific authorization audit logs. So that comes from the auth data plane services. Whenever a request is authorizing, they generate one event.
So
And
these let's say Confluent is a managed service. We are allowed to see those logs, or we are not at all allowed to see the logs, because it's a part of data governance?
Right. So the entire audit logging pipeline generate these events to customers. So they will be streamed to customer Kafka clusters, and customers would be owning the data kind of for these audit logs. We as a platform team, we deliver these data as a real-time streams to customer.
So these streams, or these are the Kafka topics, we can see that you meant to say in the real time.
Right. Yeah. So the moment you, let's say, log into Confluent Cloud, you would within, I would say, less than 10 seconds, you would see a signing attempt coming to your
No, no,
audit logs topic.
the notification comes. Does we can see those behind the whatever the 10 authorization audit logs, what the log is capturing, and how you are making sense from those logs, or this is taken care of as a service?
Uh, so as a customer, you would have a audit log Kafka cluster, right? That would
That
be
is the whichever the Kafka cluster I create.
no, not you create. So there is an internal, or I would say there is a dedicated Kafka which is there per organization, right? And then it's separate from customer Kafka, right? So this is just specific to streaming audit logs. So whenever any action that happen on the cloud or any data plane layer, the audit logs are streamed to customer, the audit logging Kafka, which is dedicated for storing audit logs.
So we can see the in the Confluent managed Confluent UI, you meant to say.
Yeah, I mean UI is not there. You have to consume from Kafka. So that is like you have to write a Kafka consumer or like consume from CLI.
Okay, so you have to write own consumer application to get those your data streaming events from those.
Kafka, right?
Got it.
Okay. Um, okay, I'll go into some of these. I would say functional and non-functional requirement. I can skip this session as well if we want to focus on the streaming use cases, right? So probably, yeah. So this is mostly around. We were talking about data security, isolation, governance, right? So all of these things. Yeah. In the interest of time, I'll talk about. How kind of we are delivering this data. So this is delivered as a data stream to customers. There are around, I would say 10,000 different customers, which is 10,000 different data streams that we are delivering to individually these customers. And then in terms of scale, we have around we process somewhat around 250 to 300K events per second. And then some of these events can be bulky. So overall, it's around 10 to 12 TB data a day. This is what we process. Okay, coming to high-level architecture, right? So on the left-hand side, so we have these like audit producing services. These are all the control plane, data plane services, which are responsible for handling customer action, right? So whenever a user do some action, the request land to one of these services. We have written a library which is again integrated in each of these services, which is responsible for capturing these audit logs, and it knows where to route these audit logs at real time. It route to one of our internal Kafka. On top of it, we have a case stream running. So K-stream is basically a Kafka processing at a client side, which kind of process these events, do some enrichment, and then produce back these events to Kafka. And then once the events are in Kafka, we have a routing layer. This is what used for delivering these events to individually customers. And for every customer on the right-hand side, we have a Kafka topic. I would say not a topic, but a Kafka LKC, which is a Confluent, like a Kafka cluster. The cluster is basically owned by customers, but managed by Confluent. So a customer can only read data from this cluster, but they cannot do any other operations like delete, update, or change any of these settings. So customer own this data, and then at the routing layer, we delivers like 10,000 plus different data stream to individually each of these customers. And then once the data is there, it's up to them when they want to consume. It is written for 7 days. Okay. So yeah, not going too deep, but I'll talk a little bit about how we are processing these events, right? So we use KStream, which is basically a client library in Java, where you can write some of these functional programming, where you can write multiple functions, which then kind of runs in an empirical fashion, where you read data from a topic, and then it goes through multiple of these functions, and then it can generate some kind of a data lineage, or I would say data flow within multiple topics within that Kafka, where like you pass this event and then you process it, you may filter it, and if there are errors, then it go through individually each of these error retries topic, and then again it can come back again to the same parse event, and until you are able to kind of say that, okay, I'm not able to process this event, it would drop, or you are able to kind of process this event and send to customer pipeline. Yeah, so far, any questions? Yeah. So basically, what is happening is that we get this event, right, from the left-hand side, and we need to know where to send this data, right? So like, as I said, there may be like a lot of events coming in. I need to know which customer this data belong to. So this is the metadata layer, which talk about giving the right tagging to each events. And then once the tagging is done, at the routing layer, the router would know that this event belongs to this customer, and then that tagging is used to kind of generate respective data stream. So what you see in middle, that is owned by us, right? Which is the processing cluster, right? And at the routing layer, we have separate clusters for every customer. And then we would be delivering data to each of the individual customer clusters. Right.
Can you go to the keystream architecture?
Yeah.
Here, multiple retry, what it means? Like, why you need multiple retries?
So basically, this is to improve overall reliability. So there are cases where, let's say, during data processing, I may not have like certain metadata. So, and then I am not able to do right tagging, right? Let's say in certain scenario where metadata is missing, or so basically what we do is that we put it to a retry one topic, which is kind of a delays consumer. So we have written a custom, I think, layer where before reading the message from the retry one, it will wait for certain X time, and then it try to process it again. And then even if we are not able to fix the error, it goes to retry 2, and then again retry 3. And then I think retry 3 is 24 hours. After 24 hours, we drop those events, put it to DLQ topic, and then that kind of ends the overall workflow.
So the retry as an individual topic, huh?
Yeah, retry is an individual topic, yeah.
Individual topic on the same Kafka cluster, or
Same Kafka cluster, yeah.
But every stream has its own events, right? So why still I not
So,
got it? Can
so,
you
so
take an example and
yeah.
explain?
So like from the Kafka side, you can do you can configure retries, right? So the retry would be that I am trying to write to a destination, and if there is a network fault tolerant or like Kafka is down, it will try to do a retry, and the retry can be infinite also. But think of a scenario where you are dependent upon external system, right? And the system is not available, right, at the moment. And even if you do a retry at Kafka, ultimately it won't succeed because system is down. So the system here is the metadata service. So I guess there was incident some 2 years back where the metadata service was down, and at the real time we didn't had the metadata where to send these events. So ultimately we ended up putting all those events to DLQ. So we had implemented this fault tolerant layer, which yeah.
Okay, so the metadata will trigger the saying that my message has not, the event is not like taken. So then you do the DLQ, means whatever the retry topic you do, whatever it is.
Right. So if a metadata is missing, let's say I don't have right destination for an event, right? Where to, which customer this event belong to because of the missing metadata, I'll put it to retry one, right? And then it goes to retry two, and then retry three, which is like 5 minutes, an hour, and 24 hour. I think this is what the time is.
Okay, based on the metadata only, the retry comes in. Okay, got it.
DLQ is a dead event queue where normally the retention for DLQ is a little higher, right? And there are less number of events generally in DLQ. So in a case where we want to fix the error and then retry those events, so that we can kind of read it from the DLQ and process it again. So it is called dead letter queue. It would increase for the specific topic because then for 24-hour topic the lag is generally somewhat 10 million for us. There are very less than 1% of the event which goes in the retry pipeline, but again the consumer will wait until the head of the queue is delayed with 24 hours, right? So I would say E6 data would come on the right hand side. Let me. So once you have, whatever we do here. Okay, where is that architecture? 1 second. Okay, yeah. So whatever we do here on the left hand side, it is real time stream processing, right? And then once your data goes to data lake, on top of data lake, eSig data has query engine, which can kind of query your data and then kind of produce analytics as well as send to multiple destinations. Probably we will cover that use case later in the slide. So I have slides on the data analytics part also, Apache Iceberg. So okay, in terms of yeah. In terms of some statics, so we are processing somewhat around 300K events per second. And then if you see, like there are around 40 pods running, which is using average 1 core CPU and then 3 GB of memory. It is pretty optimized to kind of process this whole kind of event stream. And we have larger kind of stream for the logging pipeline also, but yeah, which is not covered here. But overall, you get somewhat around 15K events per second per pod of 15 to 20K events per second. This is the throughput that we got with the kind of CPU and the memory uses. The stream is little heavy on the memory side because it do in-memory processing of the events, and then if there are aggregation use cases, which is not there, but yeah, that would be like higher consumption of the memory. Okay, I would say that from the stream processing side, I would be shifting towards the data retention side. So once these events are delivered to customer, there is an internal requirement for us to kind of store these events for 1.5 years. And then if you look at the total size, there are 10 TB daily, so there would be like around more than 1000 TB in a year, right? So that is what I think the problem that we have been facing so far, and how I think we are trying to kind of use Apache Iceberg. I think that is what we'll look at in the further slides. Okay. Okay, coming to the traditional approach, what we have been doing, I think, so before adaptation of Tableflow, so we used to have real-time data stream. We try to dump all the data in data lake, which is S3, and then use Amazon Athena to query this data. I would say this is like a 5 year back, I think this was considered to be an okay architecture pattern, because with S3, you like as a data lake, you can dump as many objects you want, you can grow infinitely. And then in our case, at least there was a lineage because we have a set schema, and then Athena is a good enough tool to be able to query. But then there are issues like Athena has a limitation of 5 TB data scan, and then there is a query runtime of 150 minutes on a single query. So if the data is large enough and there are not partitioned correctly, this would fail horribly, right? And for us, the partition we have is at a time-based partition. So at any day, any hour, you can query. But if you want to write a query which is ranging across, let's say, a month for this large data, the query becomes very slow and it won't work in some cases. Right. So in terms of access pattern, right, for audit logs, I'll try to kind of put some access pattern and see how we are solving those use cases. So access pattern may be that we are trying to look at there is someone specifically which is DDoSing us, right? Trying to do lot of action on a specific IP, or maybe doing some IP spoofing. Sometimes there may be a lot of authorization failure because someone is trying to hit a service. It would result into auth failure, but then we want to monitor all of these failures and how many of these failures is happening. And if there is a spike, that can kind of trigger an alarm that someone is trying to do a DDoS service, right? Or a DOS service. Basically, that could be one of the scenario. Other scenario, I think, typically that happen that then some data is leaked or API key is leaked. And in the security world, I would say that the leak is always detected 6 months when that leak. I mean, if you see all of these news, you will always know that okay, some 1 year back, some data was kind of leaked in the world, and then you want to come back a year back and then see okay, what had happened, right? Or what are all resources was accessed. So that would become a typical pattern for the InfoSec team to be able to kind of generate some insight or on top of audit logs, right? And then there are some other typical operations that they do as a day-to-day monitoring. So that may be that, okay, how many resources are being created, updated, and if there is some kind of an anomaly that could happen during the create or update, if there is a spike, it means that there may be some external attackers is trying to kind of harm the system. So in terms of the architecture, what we discussed earlier, so I think Athena S3 with DDL tables would work very fairly, but in a case where you with the data of this size, it doesn't work typically for us. And then we had faced a lot of issues in the past where we were not able to kind of generate right queries, right? And the query typically takes more than an hour, right? If you're trying to run like a multi-day query or a month query, it can take, a month query won't work at all. So at max, I think you can query some 5 days or 4 days maximum with Athena DDL, with this data size. And then the partitioning problem is always there because either you partition based on some other fields. In audit log, there may be like lot of fields like principal ID, IP, resource name. So it is very difficult to fix one field on which you can partition. So that's where we have used time-based partitioning, which is efficient in the storage part, but then querying become very difficult here. Yeah.
So, what are those typical anomalies that you are required to report?
So we as a platform team, we build this, and then there is a security team in Confluent which kind of use this product to detect the anomaly, and they have their own kind of access pattern and the monitoring behavior that they use.
The reason why I'm asking that is, what is the SLA that the customer asks, let's say an incident has happened and, within a stipulated SLA, what does the customer typically say?
Yeah, so I'll give you an example on the same, right? So based on the customer escalation, there may be like a 7, sorry, which can have an SLO of within a 1 day you have to kind of finish the investigation. It may be a SEV2, which is like something which has to be finished within 5 days. It may be a customer question where they're just trying to understand if something would have happened. So based on customer incident, there is this there is a whole process. Security incident would be
Then
created.
Athena and S3 would still satisfy that need, right?
So typically, Athena, if there is a specific date that we know on which the action happened, it works well because the date-based partitioning gives you very good kind of space where you know on which date you are trying to search the data. But there has been cases where, let's say, I don't know for a month, and then it is very typical for at least use this kind of a query based on Athena, right? On a kind of a partition based on time-based tables, right?
Like, can I answer that question? Okay, so your question is more on if there is an SLA. Okay, how are we going to? What is the tool that you would ideally use, and will this scenario solve it or not? Right. So I partially agree. Athena may not be the right tool for you. If you have a very strong SLA, depending on the complexity, of the data that is underlying, okay, and if you're running complex joins, if you're having millions of records, if your SLA is, in few seconds, then you would need more of a, massively parallel processing kind of a system like Redshift. Okay, so that will actually address, the SLA part of it. Okay, Athena is a query engine. Athena is under the hood of Athena. It is Trino. If you look at, I don't know how many of you have used the most recent version of Athena. It is Trino. Okay, so earlier it was Presto. Yeah, now it is Trino. All the ad hoc queries, all the interactive queries, all the exploratory data analysis, for all of that, you can use Athena. Athena is a serverless service, right? So it is very easy. You don't have to provision any, clusters for that, etc. So it's very important for you to use the compute based on your workload. Okay, if you are driven by the SLAs, it's not just
compute,
it's
that's
purpose-built compute. Yeah, that's
That's
the
what I
way
was
to-
trying to ask him. So if you are well within the SLA requirement, then no need to change.
Well, end of the day, what determines is, three things, right? Cost, performance, and experience. Everything that we talk around, falls under these three things. When end of the day, when business decisions are really made, it is about cost, performance, and experience. With what experience you are getting. So when you're talking about, the SLA, it talks about the performance. It falls under the performance section. As long as your SLA is being met, as long as your objectives are being met, you don't have to search for a problem, because you have a solution. That's the.
And good to see AWS batting for Confluent, huh?
They are one of our best partners. So E6 is one of our best partners. So yeah, that's how it is.
Yeah, I would say that. I mean, we were there was some crunch already, so that's where I think the next slide will cover how we are able to mitigate this, right? And this was, I think, a year back when we say that okay, these are the issues. Yeah.
So is that static architecture or you're using some zookeeper operators to scale?
Sorry, not the Kafka pod. It's a K stream. I mean, it's a service, right? A normal service which is deployed. Kafka, it's a separate managed data plane service, right? So.
Oh, okay. And what about the 1 year data? Are you storing as a hot storage, warm storage, cold storage?
Yeah. So basically, the cold storage is S3, right? So it's been archived in S3 for 1.5 years.
Okay.
Right. Okay. Coming to Apache Iceberg. So I'll talk about in brief what Iceberg is and how it tailor fit to this use case. So Iceberg is an open table format, which is on top of your data lake. And in the current modern terminology, data lake can be considered your renting a computer in Jeff B or Nadella or anyone's computer, like kind of a object store, right? Which is the data lake of the world today. And so Iceberg, what it provide is some kind of a metadata layer, which is, think of a scenario, right? You're trying to search Athena in the previous slide. You would do an order of n scan because you have to scan each and every object, because the partition is time. So time derives which folders you're trying to go in. So you are doing an order of n scan, whereas in case of Tableflow, it's like optimized in terms of your search, because you are doing log n scan, because you know which objects your data can be, because of there's this metadata layer which talks about, okay, which files to choose for the searching use case, right? So this is what I think high level Iceberg provide, and then it manage these metadata layers in few components, which is called snapshot. Snapshot is basically nothing but kind of a real-time view of your data. And then every time someone adds a new data, there's a new snapshot. And then Iceberg manages the entire lineage of these multiple snapshots. So at a time, whenever there's a query, it knows which files to pick up, right? In terms of the feature, if you look at, you can kind of evolve your schema, which is, I think, one of the best thing. Like you can add new fields, you can delete fields, and Iceberg will have the lineage based on the metadata. And again, at a querying side, you would not have to kind of build another S3 bucket or another data lake, so that you can query on top of your data. Yeah, other things maybe that, okay, it manage partitions inside. You don't have to kind of do some kind of a like custom implementation for your partitioning. Queries are optimized. We'll look at some of these queries. And then I think best thing is that it's an open table format. So I think engines like Athena, Spark, Presto, Flink would work out of the box. Okay, so this is a typical architecture for Iceberg. So on top of it, you would see like a metadata layer, right? So this is a glue catalog which would hold the actual schema, and then Iceberg has these metadata file, which talks about specific of the table at the real time. So for an example, today the metadata file will talk about, okay, what is the today's schema. If there is like some change in the schema, there will be another metadata file, and then it'll talk about what are all snapshot it is capturing. And snapshot would be kind of the view of the data at the time. And whenever there are new data added, it'll be new snapshot. So metadata file will kind of have all the lineage of all the kind of snapshot that happened in the past. And then these are the manifest file. So manifest file is basically, okay, what it does is that it gives you these some kind of metadata, and the storage layer is Parquet, right? So it support multiple, at the bottom layer, it can have multiple like ORC, Parquet, Arvo, but in our case, we are using Parquet. Parquet is like a column oriented storage layer. So it contains these stats, like for an example, I have dates. So it would have what is a min and max date. I may have some fields. It would know what are all ranges of those fields. So it would be kind of containing those stats, and those stats would be kind of added in the manifest file. And then whenever the query is happening at the top layer, what we would know is that, like for an example, like a binary search, right? So when you're trying to search, you know where to go, right? So you can go left or right. So it gives that kind of thing, right? Where you would know which data files to scan, and based on that, your queries would be very fast. Okay, coming to Confluent Tableflow. Want to talk about it?
Hi all, Devanshu here.
Can you go back to the previous slide? So that Iceberg catalog, right? Let's say it is pointing to one metadata file at a single point of time. So let's say I change some fields, so it will create another metadata file, right?
Right.
And I deleted also some fields, then it will be another metadata file.
Yeah.
So like that, then my metadata layer will go increase whenever I have to do a lot of file of reason. So who manages those metadata layers?
So I
Because
would
the
say,
pointers are, see, you are pointing from the catalog to there, then who takes care of the catalog management, all these things?
basically there's something called compaction, right? Compaction, what it does is that it can compact or delete older files, but Iceberg natively support time travel. So today, let's say, in most of the cases, when I do a query, I can say that, okay, select this from this XYZ field. I would be picking the latest metadata file, right? Which would have latest set of snapshots. But if I do time travel, I can always go in the past and then like specific point in time, I can say that, okay, query from this snapshot or this metadata file. So that would give you, but to answer your question, the management has to be
I
done.
got it, how the Iceberg works, like this I know the concepts. But let's say some fields are deleted, some fields are added. So all these things will be a metadata file, right?
Right.
For let's say I have a 5 fields in some table, so that these are a lot of random read, write, or delete operation happens. Then I'll be getting a lot of snapshot file. Understood, right? Because if I have to travel a long time, I have to keep every pointers. So, yeah. Huh. No, compaction is the process of compacting it to a smaller size. That I understood. Huh. Yeah, won't be there. But see that manifest files again. It is a data file. If you see. So then in events, let's say 1 year, if I do that, then in my iceberg is very huge, right?
That also happen with even if you keep the Parquet file, right, normal data files, without any open table format, let it be Iceberg or any other things, that same problem will happen, right? Let's suppose you are simply storing your data without any open table format, and you are keeping your data, and every data will be immutable in your S3 object storage. Let's suppose today you have 5 Parquet file, you applied some delete operations or some insert operations, you will actually create another Parquet files, correct? And either you can merge in memory and then overwrite the data, then only that is some sorts of compaction only. What he's trying to say, that you have to write some sort of compaction job. So if because with times your data will increase, and with every CRUD operations, delete, insert, and every other things, your not only your metadata plot will be there, even your data files will
File
be
also,
yeah, that also will get lot of you can say in a very simple sum, it will lot of data will be there, right? Because of that reason, on Iceberg, there are a lot of tools, open source tools, which is coming into market, which you can use to compact the data over certain period of time. If you don't compact your data, obviously, that was the problem even in a data lake. That problem will always arise even in the data lakehouse world. So what he's trying to say, that Apache Iceberg is responsible for that metadata layer. So even if you are having multiple operations, obviously it is going to block. But the thing is, it will always point to the latest data. Until unless you need a time travel, they are not going to scan it, because there is a one catalog which is actually pointing to your latest metadata, and your latest metadata is pointing to your latest manifest files, that is which you can call in snapshot, and which is pointing to your latest data files. So what will happen, that you will always have a less data to scan. But if you want to do a time travel and you are not compacting your jobs, right now today Iceberg will not do the compaction by their own. Someone has to do it. So it's like a Iceberg, in my mind, I see it's a very dummy format, right? It's a very dummy format, which is giving you one metadata layer, so you can burn your data. You don't need to partition it, right? But if you don't compact it, obviously same problem will happen, which used to happen in any in any data
Previous
lake
data
world.
lake, yeah.
Yeah. So, but there are a lot of tools
But
right now.
any specific tool, like
S3 table. S3 table can is one of the tools that you can see.
what is the timestamp, like travel backside, they can go previous timestamps in S3 table?
Sorry.
The previous timestamp, how much travel they can go in?
You can until you like compact it and you try deleting it, because see, nothing is getting deleted, right? So if you see this in the beginning, you have this particular data file. Tomorrow you have this particular data file. So nothing is actually going on. So you can actually do the time travel. It's up to you. Until unless you say that, okay, I'm going to kill this much of data, compact it, remove it. And otherwise, as for, yeah, it will have, with the infinite number of how much from the day it started, you will have all the data in your object storage, and you can always do the time travel. So that is the thing.
Then you will be paying the same amount the previous data lake layer and this. If
No, no, no.
unless
That's why
until
I
you
tell
do
you,
the,
right?
unless until you do the manual compaction and deletion.
No, but you are overlooking the things of, so what happens in a normal object storage? You will have one partition folder, right? You will have a partitions folder. You have to scan that particular partition folder. And let's suppose in your, when you are firing a query, if your query does not contain a partitions key, like in your where clause, you are paying a lot. You are, because it will always do the scanning.
Scan everything.
But
Yeah.
when you have this type of manifest, like a layer like Iceberg, it can be Pymon, Apache Pymon, anything. But when you have the metadata layer, any querying engine will find it very, very easy to find that particular files. So that gives you a lot of benefits. But
So the query processing time and consuming and this one will be done. But when I am doing a time traversal, I have to store all the data, right? So there I am paying for the data, right? Whichever storing, because I have to travel let's say 1 month back.
Yeah,
I
yeah.
have to store every file, every metadata, every operation also.
Yeah, yeah.
So my use data lake architecture will be more data storing of the data, right?
I'll just take this. So basically what you're saying is that if I'm using time travel feature and if I'm not deleting the files,
Yeah.
I'm paying the same amount as I would otherwise pay in S3.
Paying the previous
The answer is yes, you will pay the same thing. Okay, now why should I even think about the time travel concept? Okay, many times that you want to go back in time and then see what is the data set like. Okay, this is some discipline that you will have to bring in running the data lake. Okay, if you have that discipline of, hey, I don't want any data, to keep the snapshots of all this data, whatever has generated for the last so many years, but what is important for me is maximum last 1 year. Okay, that is what I will do the time travel. Beyond that, I don't need. That is the condition that you can put in Iceberg, okay, through S3 tables, where beyond 1 year, the data will be purged. So as a result, you will not have all the data. You will just have only the data which is for the last 1 year. Hence, it's very important for you to know what is the type of data that you are storing there, what you will be using it for, whether is there a use case for time travel. Why do you even have to put all that snapshot for 1 year? You can even just remove all of them, in the last 1 month, right? Beyond 1 month. So you can even do that. There are use cases like that as well. So the idea of a open table format is to bring the transactionability for your data lake. Until now it is immutable, now it is mutable. How it is mutable? You can, through this catalog and metadata layer and all of that, it is making it look like a database. And all this is tabular data, hence you will be able to query it and all of that.
Yeah, I got it. It's
So
a table,
that,
right?
yeah, I hope it answers you.
Yeah, I got it.
Yeah, ultimately, Iceberg is not a managed service, right? So these are options you have, right? If you want to perform the compaction or retain the older data. Okay, coming to Confluent Tableflow.
Hey guys, quick time check. I'll keep this short. Now you are convinced why to use Iceberg, why to use Parquet, what are optimizations are there. Now it comes to implementation. If the implementation is complex, that creates a friction. But Tableflow is the latest product by Confluent that is part of the whole left shift arena, whole left shift plan where you can have a particular Kafka topic. Within 5 minutes, you can do all of it, and that Kafka topic will be available in S3 where you can query it with Athena. Tableflow abstracts all of it. You just need to click 3 buttons, 4 buttons maximum, enable Tableflow, choose either your own bucket or Confluent can manage your bucket. Choose BYOB, that is bring your own bucket, or Confluent manage bucket, and then click confirm. Within 5 minutes, every record in your Kafka cluster will be available in the S3 with Iceberg in storage as Parquet format, which is optimized for most of the things. We have all the Iceberg, everything good about Iceberg is implemented, it's all abstracted. Implementation is very easy. Yeah, this is what I did for audit logs. we have a Kafka cluster where a particular topic, we have two topics for two types of audit logs. And we could see on the left-hand side, we have the audit log Kafka topic, where we have the logs coming in about 5 TB per day. And then we enable Tableflow on it. Tableflow will automate, abstract everything. It will materialize the topic, which is we use JSON for our events. Now JSON is converted to Parquet. Iceberg metadata is materialized and is stored to S3. Even if you evolve the topic, you add let's say you add a particular field, Tableflow will take care of it. It will pick it up from the schema governance. It will sync with the AWS Glue catalog. It will sync with S3. Everything will be automated. It's very easy to use. And then you can use Athena, or there are a bunch of options. I can't even remember all of it to query. You could use Athena. You can run PySpark locally. You can run Athena PySpark. You could use Redshift. You could use Snowflake. We have also now introduced Delta Lake and other support. Yeah, the first one you could see, query one, is a comparison I did as a part of POC. Yeah, I'm using Athena SQL, that is basically Trino to query the S3 tables. Yeah. So Athena was never the problem. The way we store the data in the data lake was the problem. So now it's Parquet. So originally we used to store JSON files, which are just rows. And when you query using Athena, it will scan the entire record. Now, since we are using Iceberg and Tableflow is converted to Parquet, now that data is all columnar. So if you see a typical query, you could see I'm, let's say, selecting a method name, a subject, a resource name. So when I run this on Athena, you can use anything. Right now we are using Athena. It won't scan all the fields. It will only scan those particular columns. So you could see the comparison there. Originally, where we use JSON, we did not integrate Iceberg or Parquet files. You could see a runtime for this was about a very small data set, like a very small POC. You could see the runtime was about 10 minutes. But when we integrated Iceberg and used Tableflow, the runtime went down to 8 seconds. That's about 50x improvement and 90% savings. And you also, Athena cost like bills you on the data scan. You could see the data scan also reduced from 197 to 5 GB. So that's the power of Iceberg, Tableflow, Parquet files that we implemented using Tableflow.
So still we are using Athena to query, but in a different format.
Yeah.
Yeah, let me take this. Right. So basically, Athena is a query engine, right? So I think what E6 data is also a different query engine, right? So the typical approach is that you put your data in S3. This is what we used earlier, and then you are generating these files, which is JSON stored file, right? And the metadata layer of the file, what is there in the file, is part of your S3 object key, right? Based on the time you are creating folders and the files, right? And now if I want to query across time, I need to scan entire S3 buckets, right? Which may be like for 100 days, you are scanning 500 TB of data, right, for us. So that is a pretty huge data scan, right? Where in case of Iceberg, first of all, the format of how you store the data. In our case, we use Parquet. So Parquet is columnar database. So when you scan a single file, you don't have to scan entire file, right? You can scan the specific columns. This is, I think, the power of Parquet, right? So in the query, if I am selecting, let's say, 3 fields, I'm not going to scan the entire file. The file may be of 100 MB, and then the data scan would be the partial, which is only for these fields. That is one advantage. The second is that I'm not gonna scan entire objects, right, S3 objects, because the Tableflow metadata gives you, Iceberg metadata gives you which objects to scan, because it can kind of has these metadata around each of these files. So you would be not scanning entire bucket, but let's say this few set of objects, right? So this is overall, I think, the data scan would be reduced. Now, Athena just is a query engine. There could be like many more other possibilities for the querying this data. Athena is just one option for which we use, which because easy of onboarding and easy to use.
Okay.
Yeah, me.
So you want the difference between what is S3 table and Iceberg. Okay. See, basically, Iceberg is a self-managed open table format. That means you'll have to do compaction by yourself. You'll have to, retune the manifest files by yourself. You need to delete the snapshots by yourself. All these things, something that you are supposed to do. S3 tables did not invent anything great. It's just that S3 tables is a managed version of your Iceberg. Instead of you doing it, S3 table does it. All you have to do is that you just have to configure how you want it, like the time travel and stuff like that I just mentioned. Okay, you have to configure it, and S3 table will do all that, manageability of your open table format. That is the only difference. Under the hood of S3 tables is Iceberg. Okay, plain and simple, Iceberg, no other innovation. It's just that, okay, a little bit of, speed, right? When you read from S3 table, it's 10x faster than when you read it on Iceberg, because that is the innovation that S3 brings in. And just a small trivia, when Netflix and Apple, came together to build, Iceberg, it's actually around S3. The innovation has actually started around and on S3. So it is very natively, aligned to the concepts of S3. So that's one. I want to go back to the other, a lot of questions that I'm seeing here. There is a confusion about these tools, how they work, etc. Right? The most simplest way, this is how I learned. So the most simplest way is that broadly everything falls under storage or compute. All you have to determine is that, am I storing it or am I computing it? Your query engines falls under compute. So whether is it a compute related tool or whether it is storage related tool. When we are talking about partitions, it is storage. So the moment we have this segregation in our mind about storage and compute, things become very easier for us. So then we can think about what innovation is going in what. Okay.
Kind of same. So basically, Flink is stream processing, right? So think of this case where you have a data stream. Now, Flink is a compute engine which can kind of process your stream, aggregate it, kind of transform it, right? And then it has the ecosystem of like multiple data sources, right? So Confluent, what it support is Kafka, from Kafka to Kafka. But there are other use cases where you can pull data as a file to Flink or from a different data sources. Flink also support pulling data from Iceberg table also. So it's a stream processing, whereas Iceberg is a storage format. How do you store your data? Tableflow. Yeah, Tableflow is an implementation of Apache Iceberg, right?
Tableflow does not support a stateful transformation.
Yeah.
So Flink will have lot of complex things, like you can have to you can do watermarking, you can apply multiple
Terminology would be Tableflow is like an ETL. Okay. So Tableflow encapsulates the ETL. So let's say if you have to move data from Kafka topics, right, to a tabular structure like Iceberg. In the old world, right, we typically use an ETL tool, right? But Tableflow is Confluent's own version of extracting, transforming, and loading the data from.
I think they don't support transformations.
Right now, transformation is not supported.
Yeah, but it's like a stream ingest which can fill the gap of operation state to your analytical state. Just move the data, because in Kafka you cannot do a lot of your analytical things.
But Flink also does the same thing, right? Kind of.
So
is that not the right way to compare?
Flink is plus plus, because in Flink you can
So
do a lot of SQL.
what you could do is you could merge, like you could use Flink for the transformation. Flink is, as he said, Flink is the compute. You could use Flink to transform, move data internally to Kafka.
You're also doing something very similar to that, right?
I think you people are actually not reading Kafka topic. You are reading the directly logs of your Kafka and then dumping the data to Iceberg, correct?
No. So it uses Flink underneath when it
uses Flink underneath.
Right, but the difference is that it's just materializing your Kafka topics as Apache Iceberg tables, right? Which is again real time moving your data to Iceberg table. That's it, right? Because otherwise Iceberg is something you have to manage, right? If you spin up new instance, you have to manage all the things, which is done here automatically.
Ankit did touch upon partitioning, where before the whole pipeline is deployed, you have to think about what key fields you want to partition data on. But kind of column stars is a feature that helps here, where column stars basically stores particular statistics from a data block, let's say minimum value, maximum value, and that allows us to have partitioning on every field. So you could here say query 2, where I run a particular query where I have not used the date. Now for query 3, I have the date. Ki I know on this particular date, I want to aggregate the method name. Now you can see the data scan reduced from 75 GB to 1.5 GB, and the time is also reduced. Now I could do this, let's say, for something else. I know the method name. I can use method name to kind of partition the data. I could use principal, I could use IP address, I could use anything here to partition and kind of reduce the whole query time and data scan here. That's a flexibility added by Iceberg, you could see. Now, key takeaways would be data governance. The data evaluation is very easy. You just change your source, add a particular field in your data schema in the schema registry. Tableflow will take care of everything else. It will start populating the new fields. Scale, it's auto for scale right now. It's about 5 TB per day, but you can scale up to petabytes. It's auto scale. You don't have to tweak anything. Vendor agnostics. Now, as we discussed, we are right now using Athena here, Athena. But let's say if you want to do something more, you could use PySpark. You have a quicker SLA, you could use Redshift. You have other use cases, you could use Snowflake. So it's up to the customer, up to the user, how they want to use it once it's in S3. Storage efficient, takes up less space, it's columnar. You could optimize your queries also to reduce the runtime and data scan. Yeah.
Authentication means?
It's part of the audit log.
It's a so the whole implementation was done on top of audit log. So the examples is real time examples at what. Yeah, it's a field. Yeah.
Does Tableflow also manages this compaction part of Icebergs and all?
Yeah.
So it's like a similar to the S3. The only other thing is ingestion part extra top of S3 tables.
So basically, you have a Kafka topic, right? You enable Tableflow, and then that's it, right? The only management you would have if you want to, let's say, evolve the schema, right? You want to add new fields and you want to evolve the schema, so that has to be done by you. And once you do it via a schema registry, it would manage that. Right, Tableflow automatically understand your updated schema and then kind of manage your Apache Iceberg tables.
All the compaction.
Yeah.
It's that is just select topic, enable Tableflow, choose your own bucket or Confluent manage bucket and confirm. 3 buttons, that's it.
Yeah, okay, got it. And one more question. Are you connecting to the cluster as a consumer or directly reading the log file?
Yeah, I guess it does not start a consumer. Right, I don't see a consumer group running. It uses Flink underneath, right, to connect the data.
Okay, but you're directly pointing to that log files, right?
Yeah, that I don't know actually.
Okay, fine. And one more question regarding the Iceberg. It might be silly. So I have seen a lot many people doing CDC to Iceberg, right? So what if there is a case in which there are lot many upserts? So how good?
Lot many, sorry?
Upsert.
Okay.
Yeah. How good Iceberg works in this case?
Iceberg does not support upserts.
So copy on write.
V3 version of Iceberg.
Okay.
So right now Iceberg does not support upsert. It is planned in the V3 version. It's not like a ODB where you can do the upserts. But yeah, in the recent, they are one of the major release that they wanted to do in the V3 version. Currently right now Iceberg in the V2 version. Yeah. So they are going to give the supports of upserts and the variant data types, and also they are removing the deletion vector. So they are introducing the deletion vector. There are 3 things which is in the future scope. So right now upsert, you have to write your own merge command, the way you do in Spark, like you write your own merge command, read the existing Iceberg table, combine it, and then apply the
so the copy on write and merge on write.
But it's not like a hoodie where you just mention your partition key and mention your field on which you have to apply. Like it can be updated date. and it will apply the offserts on the fly. So Iceberg does not support right now, but in V3 version they are, and I think V3 is going to release in this year itself, as far as I know. So yeah, so in V3 version it is planned, but right now offset it is not planned. Are you people like doing offset? I think you people are just appending the data in the.
So my question is, what if there is a CDC and there is a table where in which there are a lot of upserts and we are real time? Okay, fine, got it. Thank you.
Yeah.
Yeah. Can you throw some more light on how does Tableflow supports the varying schemas? So let's say a message having 5 fields initially, and in the second schema, let's say like I have deleted one of the field, right? So it has become 4 fields now. And again, again I'll add 2 more fields. In the third message, it's going to be 6 fields. So do you do the snapshotting for each of these messages, or do you default the values? Can you throw more light on this thing? How does Tableflow is handling these scenarios?
So from the Tableflow side, right, it uses schema registry, right, which is a Confluent feature, like at least for the data lineage part, right, as a source of truth. Underneath, it uses, I think, Apache Iceberg. Like whenever data is stored, every time you add a new field, it would generate new your metadata file, and then you would have those list of your metadata files, right? I don't know underneath whether um, uh, Tableflow kind of takes what are all things, right? Underneath, I don't know, like exactly if it does some kind of deletion of the old metadata file, but most probably, I think right now it is not doing that, right? So you would have, if you have done multiple such operations, you would have so many of these metadata files, and your latest snapshot would point to the like the latest metadata file, which you can do time travel to query to. Athena don't support time travel, but yeah, if you use some other querying tool, you can use time travel to query the oldest snapshot.
Otherwise,
we will take the next questions. They are Ankit and Divanshu are here only. In the break, we will take just to keep it short, because we have already covered more than 2 hours, right? Near to 1 point. Yeah, we will take break for 5 minutes, and then we will start our next talk.
Thank you, everyone.
Thank you. Thank you.
Thanks, everyone.
Okay. So my name is Ravi Kompella, and my role is analytics specialist. So that means, though it says analytics specialist, I look after the business side of it, in India. Analytics only, data analytics. Okay, so what we are going to talk today is about the new Amazon SageMaker. How many of you have heard of SageMaker or worked with SageMaker? Yeah, great, awesome. So I think it's it will be very interesting for you to know what is coming up, and definitely one question is SageMaker is such a well-established product. What is that new thing that we are going to do, and why come up with another product, right? So some basic understanding. We all know that the technology is changing. The kind of people who are using is totally getting diverse. And every organization is trying to see how they can make use of data. So I'm from the time where microcomputers were a thing. Okay, so it's that time. And the way I look at customers adopting data is growing really, really fast. And I see some of the people like even travel agents, who you wouldn't think that they would be thinking data oriented. They will be taking data oriented decisions. Even they are taking that kind of they're moving towards the data. So it's become kind of a norm. It's like how it was ERP once upon a time. Now it's like data is like given, right? So in all these things, what we are seeing is that AI is changing the whole thing, right? So I'm actually taking a step back. So we have seen all the flow charts and coding and all that in the previous session. So I'm just taking one step back, and it will not be only this English for you. It will also talk a bit of what we are trying to do, right? So in the pursuit of creating new experiences, why create new experience? Because new experience actually lead to adoption, So any business is now focusing on experiences, be it a customer experience, be it employee experience, be it partner experience, anything under the experience heading, right? Everything that we do. In fact, we have seen, E6, present their beautiful slide, right? What they are trying to do is that the end of the day, they want to create that great experience, right, for the people who use it. So then, the second thing is that productivity, boosting the productivity is again another important thing so that we can do more in less time, deliver insights and so on and so forth. So in this pursuit of the way we are leveraging AI, what's happening is that, this goes without saying, I see a lot of people, in fact, today at least 3 or 4 people spoke to me about the kind of Gen AI projects that they are working on and to drive the, innovation in their enterprises. And day in and day out, I meet tons of customers, and everybody is, gold on building Gen AI-based application. So just like how this Iceberg, quote unquote Iceberg literally, depicts, while the Gen AI application is just the tip of the iceberg, the most important part is the, under the, water. Water is there. So the foundation of the Gen AI application. I think that is one area which many people would not want to touch also, because that is the most hardest part. So that is where the trust in the application actually generates. And I think as data workers, so we call this, I like this term data workers. So data workers, basically we are talking about data engineers or data scientists, analysts, Gen AI application developers. All these are data workers. So I think the most important for you is that to basically go below the layers, 3 layers below, and then see, what is the kind of data that you're getting, how is it that you're getting, so on and so forth. So in this pursuit, what we do is that, we do, big data processing, we do multiple kind of activities in this whole life cycle of, a data journey, right? We do a big data processing, we run SQL analytics, we have heard of this, Athena, Redshift, Snowflake, all these are SQL analytics, of course, machine learning and Gen AI. So now, what's happening is that the roles are not, stonewalled. The more we are seeing is you don't call. I just happened to meet one of our friends here, who introduced himself as he is a data science analyst. Okay, see, you can see the role, how it is, and I get to hear this a lot. I'm a data science engineer or a data engineer scientist. That means, there is a lot of blurriness between the roles that is, forming. So that means that, it is actually the industry is basically asking for a unified experience. I don't want to actually prepare something, build a pipeline, and then, data scientists wouldn't know, where to get, or there is a huge process for them to seek that, from the data engineer, and then, data analyst wouldn't even know, what to get from whom and where to go, so on and so forth. So all these walls are needed to be broken. So basically, what the data users really need is a unified experience to have an open collaboration. Okay, so that is the problem that the new SageMaker will solve. So the new SageMaker, I can call it as the SageMaker Unified Studio. Basically, is of 3 layers. Think of it like the topmost layer basically addresses how do I bring unification at the developer experience. So when we talk about developers, we are talking about data engineers, we are talking about data scientists, we're talking about data analysts, Gen AI application developers, anyone who is developing, how do I actually unify at that layer, across, that's why you see this data processing, SQL analytics, model development, all of that, right? So you would be using, a lot of, query editors, or, Jupyter notebooks and so on and so forth. So the top layer, focuses on unification of that. And we'll talk a little bit about, what does that mean. Then the second layer is about unification of data governance. So today, again, data governance is one big area where everybody is focusing on, and they would want data governance to be taken seriously because the more proliferation of AI, governance is actually taking even more importance. Okay, and people are talking about, and they want to implement things like data democratization. I don't know, of late, it kind of became a norm. So data-driven decision making is is a way of life for every organization, which means every individual in the organization should be able to have access to data, okay, irrespective of only the data team and the people who are managing the platform or the executives. And everybody should be able to take decisions based on the data that they have. Okay, so data governance. So the second layer talks about unifying the data governance layer. And the bottommost layer is the lakehouse, which is basically unifying your data warehouse and your data lake, okay, into a lakehouse. So all of you are aware of what a lakehouse is. Data, typically, data lake provides you, the cost advantage, and data warehouse provides you the performance advantage. So it's basically the combination of these both is where, in its most simplest form, the lakehouse is. So let's look at, what Unified Studio is. Let me dive a little deep on, what this Unified Studio is. So the main purpose of Unified Studio is to provide seamless access to data, okay, and all the resources and all the tools to everybody. Okay, so when we are talking about, so what does this mean? We are talking about data, we are talking about code, we are talking about, models, we are talking about different types of compute. When I talk about, see, earlier I was just saying that everything falls under this, okay, yeah. You have any question? You don't have, right? Okay, I thought you have a question. Okay, yeah, please. So, yeah, I was talking about, everything we talk about classifies under, either compute or, storage, right? So when we talk about compute here, we're talking about all the Athenas and, all the various services that, you are aware of. And we'll talk about that as well. And how are we going to provide all this, unify all this? We are just going to have one, Jupyter notebook. Okay, so that Jupyter, you don't have to now. What is happening is that people who are running their workloads on AWS setup, they have notebooks in EMR Studio. Some of them have it in SageMaker. Some of them have it in Glue Studio. So each one has a studio, and our customers did tell this that hey, you have studio for everything. Which one do I use? How can I just use only one? Okay, this is your answer. Okay, just use one studio, have one Jupyter notebook where you can run all your code. One SQL editor, you can query your data lakes, you can query your data warehouses. You can use any of the computes like Athena or Redshift. And in fact, we are also opening up with Snowflake connectors and all of that, so that you can just integrate them also under the hood of SageMaker Unified Studio and use this. And then there is this entire IDE of Bedrock, the integrated development environment for GenAI application builders. So one big advantage with Bedrock is that, as you all may know, again, I'll just talk about that little detail towards the end, but it kind of provides you a catalog of LLMs, right? Because whenever you're building a GenAI application, in your enterprise, you're not limited to, only one LLM, because the kind of use cases that you have, wouldn't need or wouldn't suffice with only one LLM. So in that case, how are you going to manage while keeping everything intact? So that's where this, Bedrock comes into play. Though, Bedrock took a while, to come into the market, there is a reason for that. The reason is this, because we understand GenAI so well that one LLM wouldn't be sufficient. And instead of you jumping between LLMs, to build your applications, you should have one IDE where you can bring all of them together and then build it. So how does it work? So it's very simple. The first and most important thing, innovation that has happened is that this is an out-of-console experience. Okay, so that means you don't have to remember the URLs of all your workloads. You just have to understand, there is one URL that you need to, remember, okay, and that's what, will actually, through your, login, it can be integrated with your SSA, with that single sign-on, you can actually log into, the SageMaker Unified Studio. So once you get in this, see, because it is, out of console, that's a big advantage for a lot of people to even socialize it to larger, group. So once you get in, what are you trying to do? You would want to, discover what are the assets that you have, okay? You want to build and you want to govern data analytics and AI across. That's the main purpose. The main purpose of SageMaker Unified Studio is this, right? I want to give you a unified experience, okay? And in the process, what you will do, you will discover, the assets that you want, and you build, okay? And, along with the governance. Okay, so if you see, this is the one, right? I can do this, I can't do this, okay. All right, so we will anyway get into the details. Okay, so the whole builder experience, is centered around something called as projects, okay. So think of it like this, entire SageMaker Unified Studio is around projects, okay. What is a project? Let's imagine that I'm an e-commerce company and I'm running multiple, data-led initiatives, and one of them could be churn analysis. I want to, see the propensity of customers who are going to churn and do the necessary things, on how do I stop that, right? So on this particular project, I have a bunch of guys, maybe a couple of engineers, couple of scientists, couple of, analysts who will be working on this. So what I'll do as an admin, I'll create a project, churn analysis, and then I'll, allocate the compute to the project. I'll allocate, the data sets, what are the data sets that are needed for the project, and I'll add people, the users, to the project who can work on it. So now in this new world, okay, say there is a new data scientist who has joined, and that data scientist will be working on, let's say churn analysis. He will just be allocated, he will just be, put under this particular project. So you don't have to worry about what compute you have to give to that particular individual, what compute can he run, what data set is he having access, what are his, authentication and authorization. You don't have to worry about any of that. All of that will be taken care of by the projects, and he'll inherit all of those from the project. Just because he's part of the project, he will inherit all of them. This is a very big move. So you have to just control at the project level. You don't have to control at the individual level. So as a result, there's a very high productivity that you will have as a team. You don't have to, particularly when you are a growing teams. And I heard someone from Capgemini, so when they will be having huge teams, right? So it's much easier when you have scenarios like this. I heard someone from 3M, so it's very easy for you to, have one place where you can actually have all the users and they inheriting based on the projects. And the beauty is that, you can actually have this integrated with a, Gen AI assisted virtual assistant. Okay, so the queue is integrated into this. So that means, if you are stuck somewhere, if you want to ask a question, obviously, what does it do? So that's the big plus. So, once, you, with that kind of a thing, you can also see that it provides you specialized support to, all your tools. So all the tools that are needed, for your data processing, SQL analytics, machine learning, all of them are, listed over here. And, when the project is being created, you can just choose which ones do you want. So every tool that you want, to perform in a data, project, are available out there. And, these are already integrated with Git. So you don't have to set up the integrations at all. So tools share access to data, so you don't have to configure again, tool specific, permissions or anything like that. Okay, and we are now working on, building more, adding more tools over here, from the third party as well. That's where I said that, we are, at some point, we'll also have the Snowflakes and other, ISV. For all, maybe E6 also, listing over here, So that's the, on choosing the tools. And the studio part, where we, where the query editors are unified. So you can now you can choose, what compute do you want. See, some of them will be very comfortable with Redshift, or some of them will be very comfortable with Athena. The kind of query engine that you want to use, for your kind of use case. You can actually choose that. Okay, and you can query lakes or warehouses, all of that, without having to, toggle between the query editor. Okay, and you can choose, the kind of compute engine that you want. And when it comes to the notebooks, again, so you can use any of the compute for the any of the languages to begin with, either Spark, SQL, Python, or PySpark. Okay, you can choose, whether you want to use EMR or Glue or any of the other local engines, if you have any local engines. Okay, and you can configure. So all these things, all what you're seeing on the right side is at your liberty. You can actually do all that, from the notebook. And this notebook is again unified across all of them. Then we have, so through this, what we are trying to achieve is, how do we collaborate and build faster? See, that is the main objective. You can prepare and integrate, data, across the life cycle, right? What you're seeing. So once we are done with that, the most important part is where the data governance comes in play. So now that we are clear that okay, through the Unified Studio, it is giving me the 2 or 3 takeaways is that A, it unifies the entire developer experience, so you don't have to use multiple tools and to develop the query editors and notebooks, etc. Collaboration will become much easy because it is you will be able to see who all are there as part of your team in your project, and the collaboration becomes so that much easy. Integrated with Git, that is another big advantage. And don't have to work on the individual data worker level, at the project level only you can manage. So with that, we will get into the data governance part of it. So when we talk about data governance, the 2 most important things that SageMaker data governance addresses are trust and protection. So one is that when we talk about trust, so last 5 years, I've seen so many data projects. They start with a great josh, and at some point, they kind of lose the steam, or maybe at some point, the hard questions will be asked. What is the total ROI of the investment that we have made? Or how much of what kind of decisions have been made? Using this data platform. Stuff like that. So, customers often tell me that, Ravi, you know what? And these are some of the largest enterprises. It's very hard for us to convert the edges, which is business, the line of business, to leverage and to make decisions based on the data what we are generating. And I'm not talking about the digital natives. I'm not talking about startups. I'm talking about someone who is like a rubber manufacturer, okay, or someone like who is into a cement factory, So going back to the beginning of the slide, I said that everybody is adopting data. So everyone, the beauty is that everyone want to make decisions based on data, but 1 year into the journey of data, the hard questions that they would get is that, what is the ROI on this platform? And upon diving deeper into why there is no ROI, okay, the trust, think it pragmatically, right? The line of business guys, they haven't had this till yesterday, and they have been working for 30 years in the same. Think about a plant, engineer, of some manufacturing plant, in cement industry. So that guy goes with that guy goes with experience. That guy goes with his knowledge on that subject over the last 20, 30 years. He will not believe what is your model showing. Okay? Why he will not believe what your model is showing? Because he can't see relevance. Because there is a steep learning curve. First of all, he can't see relevance. He will say that, okay, your data is showing something, and according to my gut, it is something. Okay. So how do we build this trust? This is one of the biggest reasons. If you, I don't know how many of you are in that journey. Okay, or have you seen this? This is the biggest one. So data quality is a big area. That has to be focused on. If the data quality is good, then the trust in data will go up. If there is lineage, if I know who has, okay, what is this? Okay, one part is that data quality. Data quality, you can talk, it's a big, broad statement. What is lineage? Lineage is, I want to know, if I have to make a day, this particular dashboard is saying that invest in, 10 different stores, 10 more stores in, let's say, South Bangalore, okay? If I have to make a, investment, physical investment in 10 new retail outlets in South Bangalore, the data is saying that, yes, you should do it because of whatever. Now, how do I trust this data? So the easiest way to trust this data is to look into where is the data coming from? What are the transformations the data has gone through? Who has done the transformations? So all of that, you'll get it in lineage. So data lineage is another very big area in order to get the ROI. Okay, now I have all this, but then, how am I actually making sure that my data is safe? I'm coming up with a lot of, Gen AI, projects. I have a big charter. The board is putting pressure on, doing Gen AI, projects, etc. Now, how do I know that, they fire, a prompt, which doesn't actually go into my secret, my, financials, and then pull out the data and then give it to them? So how do I don't want to even expose this data to the employees. So how do I protect that? So all this, putting the guardrails, having a, responsible AI, this becomes the core foundational, aspects for any data platform, which most of the, people who are, at the, who are just, firing queries and then writing code, they may or may not be aware of this, but that is the granularity. And, when you are working, how many times as data engineers here, you wanted to work on a particular data set, but you don't have access to that data set, okay? Or, where the data set is, you would be able to check it through the catalog, but you don't know how to get that, data. So, addressing those things, so all of that while keeping the logging, and monitoring on the cost is what, SageMaker data and AI governance overall does. So this is, it kind of, ensures there's trust in the data, okay, through the tools that it has inside, which we will go through. Then it talks about, how to protect the data. It makes sure that, there is enough logging and monitoring from the usage and cost, okay, so that whether, you are having any leakage. One of the biggest problems many data teams face is leakage. Where is my, I'm spending a lot of money, I don't know where I'm spending, so all of that. So, this is a very, it can be hard for you to read, but basically what it says is that, the new, see, until now, whenever we talk about catalog, let's say Hive catalog or Hive Metastore or, let's say Glue data catalog, which many people, use it. See, there is still an element of, technicality that you need to know. You need to know SQL, how to, search for a specific data set. Okay, and you need to, it is a little hard unless you are in thick of it, you wouldn't know what data set you are looking is actually the data set that you want or not. Okay, so that is where, there is a lot of business metadata that is added. This is again a Gen AI based, metadata creation and glossary. So now if I'm a, even if I'm a line of business guy, I'm a functional guy, and if I want a specific set of data to do some kind of analysis through the analyst who is allocated to me. Large organizations, by the way, they have these federated teams. There will be a central team, who manages the platform, and there will be analysts and scientists who will be working in the edges with the line of business, who will have a bit more context on the business. So for them to work, so you have this business glossary built into it. So now, people would know CTY means it is country or it is county. So because it can be any of those, right? So all of that. And then, this graphical representation of the lineage. We all have seen, by the way, this lineage is open data lineage based. It is the open source, open lineage based. So, where we are heading towards is that this entire concept is now, revolves around, centers around, domains and projects. So I'm talking about domains, a new word. Projects, we have spoken enough. We have spoken enough about projects, right? You can just look at this, this is a classic representation like any of your organization, right? You would have, your business problems you want to solve on one side, you have the data workers in the center, and then you have various projects that they will be working on, right? So domain is nothing but, if it is a very, very large organization, you can have, domain as, one organization, like one entity in which you will have multiple projects. Otherwise, if it is a small organization, you can just have one domain. Here in this case, imagine this is something like Amazon. So we are talking about e-commerce domain unit. E-commerce itself will be like a huge thing. And then I will have one domain for supply chain. I'll have one domain for, I don't know, maybe customer service. So because these are very large, right? So domain is like a, like a large organization, like a large umbrella under which you'll have the projects. So, this is basically talks about, you can just create the domain. Basically, there are two roles. One, there is a role called, SageMaker Unified Studio admin. The admin basically creates the, it's a one-time effort. They create the domain, they create the projects, and they create whatever the compute that has to be in each project, etc. So these are usually one-time efforts. Okay, so that's what we okay, we spoke about projects. Okay, blueprints. So what is so now there is this concept of blueprints, which is basically infrastructure as a code. So you don't have to create everything again every time. So already there would be blueprints, with existing, Redshift, or compute in it, some data sets, all of that will be already created, so you can directly leverage blueprints. So blueprints will actually expedite your, deployment. You don't have to create everything again, like in a project. So, when we talk about discovering the data, here we are talking about discovering the data through SageMaker data catalog. Okay, so SageMaker catalog under the hood is actually Glue data catalog. Okay, so without having to confuse you all, so I myself had this doubt. We talk about high metastore. We talk about I think catalogs. Ankur will be talking next. Right. We are talking about Glue data catalog. We are talking about SageMaker catalog. Then we talk about Iceberg catalog. I mean, what are we talking about these many catalogs? Like which one is the one that I should be actually looking at, right? So high metastore is more of an open source thing. So Glue is a high metastore HMV compliant data catalog. SageMaker catalog is nothing but adding all the English to the Glue data catalog and making it NL based. Okay, so that's the it is easy for you to discover the data. It is easy for you to look at what data products that you already have. It makes you check whether that particular data set is fit for your use case or not, so on and so forth. Then okay. So this is exactly what I mentioned. You have various data sources, okay, and you use Glue crawlers. I don't know how many of you are familiar with crawlers, crawlers basically scan through, the data, and then they build, the glue data catalog. The metadata will be, scraped through, from the data sources, and it builds the glue data catalog. So until here, okay, one has to be a little bit of having the technical, this is typically addressing the technical users. So SageMaker catalog, is a superset of this, which means, there is a bit of, more, you can actually bring and share your data across accounts, and publish with a decentralized federated open ownership. In simple terms, what you're saying is that, you can create one, umbrella catalog, which is, NLP compliant, so that it will be easy for your, business users also to access. We spoke about lineage. It is all API driven. Open lineage compliant. We are planning to get the third party. Everything that I'm talking about here, there is a lot of emphasis that is going on in bringing in the third party tools also into this, and not make this entire experience only for AWS services. Okay, data quality. Data quality, when we talk about data quality, there is something called as, DQ scores. So data quality scores is what you can see, and you can determine whether that particular data quality score is good for you to trust the data and take it forward or not. Otherwise, you can work back again on the data to see what is needed. So there is, under the hood is again, Glue data quality. You already might know that there is this service called Glue data quality. Okay, you can have the visualization, of all the metrics, with groupings and so on and so forth. Okay, so that's, you can dive further deeper into the data quality aspect of it. Now, whenever, we spoke about, a common problem where, as a data scientist, I want to work on a particular project, okay, and I need a certain data set, but I don't have access to it. I can see it in the catalog, but I don't have access to it. So we have this, publish, subscribe, a marketplace kind of a scenario where, the data producers, let's take an example, the sales guys, have their own data, they will publish the data, okay, and let's say, the product guys or marketing guys, they can consume this data. If somebody is working on, let's say, product analysis, and they want to do some, model building on, which product is working well and what are the challenges in their penetration in which region, so on and so forth. They can actually subscribe to this data. Okay, so if I'm the owner of the data, okay, from the sales, I'll get a notification saying that so-and-so person is actually seeking data, and this is the reason why they are seeking this data, whether you can approve it or you can reject it. Okay, so that's a kind of so this actually eliminates the middleman. It eliminates the control of the person who is actually managing the data. So you kind of automating everything. You can see the data, you can just subscribe to it. Okay, so then the last part is where we talk about the Lakehouse. So before talking about the Lakehouse, I would want to talk about what why we thought about the Lakehouse. So yes, when Redshift, okay, we have data lakes, we have data warehouses, right? So how many of you are conversant with Redshift? Raise of hands. Oh, wow, good. So most of you are aware. So, Redshift has come up, there are a lot of innovations that have happened in it. Some of the innovations are like decouple the compute and storage. Okay, storage is actually sits on S3, okay, but it is managed by Redshift, and it is called as Redshift Managed Storage. Okay, so the purpose is, the cost will go down because the storage is actually in S3, and when the query compilation is happening, the compute will be charged and it will have all the elasticity there. When the query execution is happening, the S3 will be charged and all the elasticity will be there. So while this is there, the data that sits in RMS is a very well curated, very rich set of data, but a lot of customers of ours said that, hey, I want to use that data using some other, compute engine, will you expose the RMS data to us? Okay. So that is where the concept of the S3 tables and the Lakehouse came in place, where using an Iceberg API we can actually expose the RMS data, and you can have either Athena, you can have EMR, or you can have any other query engines on the top, okay, to fire a query and fetch data from Redshift managed storage without coming through Redshift. So that is that is where we are kind of bringing both Redshift managed storage and S3 together. So S3 tables, I think I answered this question before itself. So basically, what it is a managed, fully managed storage for Apache Iceberg Data Lake. Okay, so whenever you run an Iceberg, you'll do file compaction, you'll do several things like snapshot deletions, orphan files deletions, rewriting the manifest files, all of that will be done by S3. And the beauty is that it is 10x faster requests per second compared to standard S3 buckets. Okay, so that's the innovation that got into this. So in a nutshell, what a lakehouse does is that see, this is a good depiction of what it does. You have Lakehouse in between, with open data access, with the Iceberg REST API, you are exposing that data to any third-party applications. That means, anything like Snowflake, Databricks, Confluent, E6, all of them can access that data. And what we are doing is that we are also removing the entire pipeline, between for now the Amazon databases like Aurora MySQL, PostgreSQL, RDS, and DynamoDB, and we call that as zero ETL. Okay, where we just you show Lakehouse as an endpoint, and they both are integrated through the it's a CDC that happens behind the scene, that you will not be controlling. It will be done by AWS. Okay, and the other part is that we are also doing something called as query federation. That means if you are having data sitting in your Facebook ads or Instagram ads, Salesforce, any of these data sources. By the way, this list is expected to go to somewhere around 30, 40, soon. Okay, so you can have the data sitting over there. You can have data sitting in these databases. You can fire a query, on the Lakehouse. Okay, and that query will fetch data from wherever the data is sitting. It's called a federated query and provides you the query response. Okay, so that's what the Lakehouse does. And the last part is on the GenAI application development. That's also one of the parts. So Bedrock is fully integrated. You can see the broader selection of fully managed, models, from all the leading AI companies are there. If you haven't started Bedrock, you should look at this. By the way, there is a GenAI loft that is going on. I don't know how many of you have attended to that or attending to that. It's a 10-day event. It's happening in 1MG Mall. It's still happening. It will happen till the end of next week. So if you get time, please attend. I'm also talking there on the data foundations for GenAI applications. I'll be talking there on Monday evening. Okay, and there is also a hands-on demo and all of that on that. Okay, yeah, these are basically the various steps that one would do, in the GenAI application development, using Bedrock. So yeah, this is the last slide. Okay, so what does it cost? I think consciously I put this slide because the cost question does come up often. Okay, so the important part is that Unified Studio is free of cost. Okay, so there's no licensing cost for Unified Studio. So all the primitives that you will be using, like be it Redshift or EMR or Athena or any of those under the hood, okay, those will be charged based on their usage. Okay, so that's what you'll be paying for. And SageMaker catalog, there is a very, very tiny. I don't know, folks who have used Glue, that the first million entries is free of cost every month, and it's a few pence after that, right, per entry. So your overall bill will be like significantly ignorable, I would say, in the overall scheme of things for data for SageMaker catalog. Okay, and like I said, for the Lakehouse, when we're talking about Lakehouse, whatever the services that are consumed for, Redshift or S3, that is what you would be charged. Okay, there is no for all this wrappers that we are talking about for the ease of use experience, the UI that I'm talking about, all of that is free of cost. So that's it from my side. Okay, I promised 30 minutes and I think we are on that. Great. So any questions? I can take a couple of them, or yeah, or I'm there for the lunch also, so we can discuss. Yeah.
So what is the difference in SageMaker and SageMaker AI? I mean, is it just a brand name or?
SageMaker is a superset of SageMaker AI. SageMaker AI is also there as part of it. So in this SageMaker Unified Studio, you'll also have SageMaker AI.
So in that case, like where HyperProd fit in?
SageMaker AI. SageMaker AI is basically a complete integrated development environment for you to build and run your AI models. Just like how Bedrock is for GenAI. So you can completely end-to-end, the entire CI/CD pipeline of your model development actually can be run in SageMaker AI. SageMaker AI is part of this.
Got it. Thank you.
On the business metadata slide you had, right? So I wanted to understand, is that feature just a provision for users to, update metadata, or is there any sort of like LLM enabling users to, enrich that metadata?
Good question. Actually, there is a, whenever data set is there, is added, you can, at this point in time, it is still manual. You have to build the business metadata, because it always gives you that flexibility to check, because if it is automatically happening, you don't know, it's very hard for you to keep a control what it is building. It may be correct, it may not be correct. So at this point in time, it is still manual. There's a button that you need to click and it kind of builds. Yeah.
And at the end, we query that, that Lakehouse querying, that's what happens, right? So is the data physically copies into any of?
Whenever we are talking about federated query, the data will not be moved.
Okay.
The idea of query federation, that is where we are heading towards. See, now a lot of organizations saying that, hey, we heard this data lake. Yep. This data lake is the next big thing and all that. And we pulled all the data into the data lake. Then later we realized that we are not even using all that data. So while I want to keep all the data, and there is a reason why all the data has to be in one place, and it is still a best practice, it should be continued. If you have data sitting outside the data lake, you don't have to worry about, okay, now how am I going to pull that? What is the ETL, the tool that I have to use? You don't have to worry about all that. Okay, you can just leave the data there itself and then fire a query. That query will actually fetch the data from there and then give you the result. So it's basically, a data in place kind of querying.
But the Lakehouse is, but to my understanding, Lakehouse is built on the top of some S3 or some other layer, right? So
Lakehouse is basically S3, right?
Yeah. So, but we are saying in the bottom that there are other federated data sources.
No. So, okay. So this is just, no, these are not data. Okay, let me put it this way. See, this is only a representation. This doesn't mean that, Lakehouse sits in between and Lakehouse sits on the top of this. It is not that. Okay. These are like, I would rather, maybe a good feedback, maybe I should actually put them on the sides or something like that, where, pictorially it will be, so to make you understand, these are, integrated. This is called, there's a zero ETL integration, so with Lakehouse without any pipeline. And likewise here also, you can fire a query and you don't have to actually move the data from here to Lakehouse.
I think a better sort of, is that medallion architecture. Right? So Lakehouse is built on the medallion architecture, right? Where you have the bronze, silver, and the gold layers.
You have the medallion architecture inside the Lakehouse.
That's what I'm saying.
Yeah.
So those are the different layers in your data architecture, right? And they are all part of your lakehouse. So the advantage that it brings you is you don't have to have a specific ETL to get the data. So everything is in that lakehouse architecture layer, right? So.
Huh. Okay, let the gentleman ask. I'll come to you next.
So yeah, my question is like whether we can, is this possible that we can test our own rack systems within this, architecture?
You can, if you are, except that if you are using, Gemini model, Bedrock doesn't support Gemini model.
Okay.
Okay, Bedrock doesn't have OpenAI. So if you are using any of the, but if you are using like, Claude, Anthropic, any other Mistral or Llama or any of those, you can use all of that.
Yeah, one more question, like the Bedrock IDE which you were talking about, right? So can we tell that it's a kind of a generative AI workspace which is meant for all the data workers, right? Can we say it like that? Like it's a generative AI workspace, like you're saying within
Yeah,
AWS
it is.
you have, yeah, right?
Yeah, it is. See, basically, that takes me to this, the next slide. See, this is all what you can do. See, with Bedrock, you can build, publish, and create a generative AI application. Okay, you can. This is a typical flow of. This is basically it's like a flow chart, right? First you will explore, what models, across various modalities that you have. You do a bit of experimentation, okay, and then you compare, side by side. You'll then build a particular. This is an example of a chat bot. You'll build the agent. You'll configure it. You'll share it, and then you'll directly start using it. So this entire a life cycle of a generative AI application can be done in Bedrock, and that can be done through SageMaker Unified Studio. And if your question is, can I use Bedrock in isolation without using SageMaker Unified Studio? Yes, you can do that. Nobody stops you from doing that. And all these things, by the way, you can do it individually. See, this is to bring. We have seen usually whenever whoever uses analytics and AI services of AWS, they just don't use only one. They use pretty much everything. That is for native integration and all that. It's got its own benefits. So instead of you running individually each one, you can actually use a unified studio. Yeah.
Yeah, that's all I have. Thank you.
Thank you.
I have a question.
Okay.
So you said like SageMaker Unified Studio, everything is free, right? Here.
Yeah.
So I want to ask you, like I have been building many AI ML based projects and I have observed certain things in SageMaker Studio. The thing. So I assume SageMaker Unified
Studio is now integrated with this.
Yeah, it's integrated. Though it's integrated, I've still used it.
Okay.
So I would like to address the principal issue, what is there in SageMaker Studio or SageMaker Unified Studio if it's known now. The thing is, when we are using cloud platforms, right, then main users, like one of the thing is GPU, right? When you build these AI ML applications and you need real-time kernel stability along with GPUs. So there are many times when you run your project or when you run your notebook, you will observe that many dependencies are involved, right? People are using cloud services in order to also, there's one reason to it, like they don't want to deal with setting up dependencies in VS Code and extensions in VS Code. That takes a lot of time. And for some people, even majority of the time goes behind that, as well as the GPU setting up. So local GPUs, the NVIDIA GeForce RTX and all those GPUs which are integrated in certain systems on certain hardware, laptops, people take a lot of time. People do that also, but main reason for using cloud service should also be like, dependencies are, you don't have to worry about that. The compiler automatically, the kernel knows what dependencies it needs. You mention all the necessary libraries, modules and stuff. The thing is, your project also comes to encounter situations where many libraries or dependencies are getting neglected, and hence that can impact your project or lead to your project not happening. That's what happened with SageMaker when I was dealing with.
Okay.
Yeah. So how do I
See,
address that issue?
yeah. So okay. So the big difference here is that the concept of projects. Okay. So everything is done at the project level. In SageMaker AI, okay, there's no concept of projects. It is still the dependency is at the individual. Okay, the individual, it all depends on the sharpness of the individual and how they are controlling all these dependencies. So with projects coming in there, you can control everything at the project level, and everybody who is part of the project can avoid the challenge that you are saying. But again, I will not just stop at this. Okay, I also need to dive deeper into what are those dependencies. Are they in control, outside the control? So all those things, we need to get into it. Otherwise, there's no one simple answer. But the larger to the larger problem, the solution is the projects, where you actually control everything at the projects level. Okay, and that will be cascaded to them.
But you do have to be a competition, right? There are many other. It's the same, like it's related because AI/ML deals with all these projects, right? So you provide them. You say you provide them a platform where you can do all this, and then even if you should consider the project side, you should consider the individual side, right? Because he or she is coming to you, and then you allow them as a platform for them to execute their projects, right?
Correct.
So how do you stand out? Like SageMaker should also give some kind of advantage to that particular individual, where SageMaker stands out from all the other platforms available out there.
No. See, no.
That is there.
No. The big problem in that is, then you will not have any control. There'll be no control. See, we have customers complaining, saying that, hey, these scientists and engineers, they are using the compute, they are just firing up the clusters and they are using it the way they want, and there's no way for us to keep a tap or keep a cap on it. How do we actually control that? So that's what this brings in. So I will, maybe there are exceptions, but I'm happy to take that offline. Okay, we'll dive deeper into it. Because this needs it's not like one answer, like I said, right? Yeah. Just one more question, please, and we have.
So I was telling that when you told there is no physical copy of the data, when you do filing a federated query, the federated query goes to different data sources and executes it.
Correct.
And where the correlation happens?
Where does the
correlation happens? Because individual data sources give some output.
See, your query engine is still the owner. Okay. So now the moment you fire the query, it is up to the query. What we are doing is that we are getting the query federation into the compute. So it will first go to the catalog. It will check where the data is sitting, and it will go to that particular data store, fetch the data. Okay, and the SLA is the compute's has to responsibility to address the SLA. So if you're talking about the SLA of, hey, I don't know where that data is sitting, and I don't even, so if there is an impact, it will tell you, like if it's not able to reach, like say it's there in Salesforce and there is some kind of a, VPC or something is stopping, it will definitely prompt you. But the SLA lies with the compute to deliver, that particular, that's where, these connectors, what you see in the other side, that is what those connectors will do. It will make sure that, we build enough engineering with Salesforce, with ServiceNow, with each one, with Slack, each one of these, so that for us, the SLA will not get compromised. So that is the engineering, that is the innovation that is actually happening now in the kitchen.
But when the federated query runs in the individual data source, once the data is found and computation happens, then that result should be come back to the copy to the main query.
It will not move the data at all.
No, not the source data, but the computation part of the data.
Okay.
The result of the data.
So what you are saying is that, I'm fetching the data from the source. Okay, so mind you, I'm not moving the data. I'm just reading it from here only. Okay, so once the query is done, it is done. It will not be storing in Redshift. That answers your question?
Yeah.
Can we? I'm okay to take, but then I don't want to steal Ankush's thunder. So we are literally bang on time. So one more question, Ankur? Yeah? Yeah. You have to take mic, my friend.
Yeah.
I have absolutely.
When we mentioned query federation, is it a necessity that source should have compute? There are other sources like Snowflake, REST Catalog, Databricks, Unity. Do you also support file federation?
Okay, very good question. See, whenever I'm firing a query, two things happen, right? Query compilation and query execution, right? So first I compile the query, okay, understand the query, break it, and then do all that. Fetch the data. The execution, when the execution is happening is where the data source, whether it is S3 or wherever, that is coming into play. So to your question of when you're when you're doing the query federation, where does the compute happens? The compute actually happens at the redshift level. Nothing happens at the storage level. I hope that answers your question.
Okay, so they directly read the S3 and do the computation.
S3 or wherever the data source are. If it is in Salesforce, it will just pull the data from Salesforce. Okay, and see, end of the day, I cannot say that, hey, my Salesforce bill has gone up because Redshift is reading data from here. I mean, that will be like, that will be not a good engineering at all, right? So that's where, these connectors that I have shown before, all of them will come into play.
And the governance policies at the source?
Governance, SageMaker governance will actually take care of that. Okay, who can actually do this? Who can actually do the query federation? All of these, the authentication and authorization is built in. Actually there is this product that we brought called Data Zone. Okay, just right before SageMaker Unified Studio. So that Data Zone, consciously we did not really, push it to everybody. That Data Zone is the unification of data governance, and that is what is there inside the SageMaker Unified Studio. Okay. Hey, thanks, guys. I have to hand it over to Ankur, and I'm available around. Okay, when we have lunch, please. I'm happy to hear and learn from you all. Okay, thank you.
Okay, so I think in the beginning I only asked that how many of you have actually used Iceberg. So I was thinking to do a deep dive of emerging catalogs, but I will try to keep it basics because a lot of people, you have not used Iceberg. So let's start with how many of you have actually heard about all the catalog which is coming, which has come recently in market? Like, do you know about any other catalog apart from AWS Glue, High Meta Stores, or Hadoop catalog? Anyone has used any other catalog apart from this? I'm talking about. Yeah, Apache Polaris is a good example. Unity Catalog has started giving GA for Apache Iceberg. I have not used at least for Apache Iceberg. So yeah, Apache Polaris is one of the thing. Any other? Project Nessie. Yeah, like, have you used it or? Okay, like what was the like Project Nessie is one of my favorite. After like I was trying to explore this particular thing, and I will give you very, very good things that why I started exploring lot of things, a lot of these catalogs. From last 1 and 2 years, I started observing that lot of companies are actually trying to create a different catalogs, and I realized that okay, catalog seems to me a real normal project. How come someone is trying to create a company out of that? Right, so I started exploring it, and I figured out there are a lot of emerging player in the market. One of them is Project Nessie, which is actually built by Dreamio, and then you have Apache Gravitino, which is going to be incubated with the Apache Foundations. Then you have Rust based catalog called as Lakekeeper, and many more. And as I just mentioned, Databricks has announced about GA availability for Apache Iceberg for Unity catalog. And Apache Polaris, I think last year it was open source by Snowflake. So there are many other catalogs which has come into picture. But as a developer, mostly we mostly use Hive Metastores or AWS Glue. And those catalogs are really okay and really good when you think about just what does a catalog really does. So those who have used Apache Iceberg, can you tell me what does catalog is actually used for? Why do you require catalog in world like Apache Iceberg or any other world? Like why do you require catalog? Why can't we directly read the data from normal data lakes, like read the data which is like in some object storage, some Parquet, ORC or Ebro? Like what is the need for catalog? Can someone give the mic?
So, from my understanding, data catalog is for mostly business perspective, where across the LOBs or business team can refer any data items in a business context, and that can be shared across, and it will give a common nomenclature for all our data lake. Whatever we
Like
maintain.
one is to keep track what we are actually, how many tables we have, all those things, correct?
Correct. It's a more towards business context. Table is more technical, right? And when we are maintaining a catalog, so we should be able to understand, okay, for this particular business, what are the data terminologies getting used in that business boundaries, apart from focusing on what table technical name or its attributes we have defined there. So it can map at some point of time, but it's more towards business to understand and correlate those data with the business boundaries. That's how I.
Yeah, that is really good answer. So let me take me. I'm taking back myself in 1.5 years back when I started looking through it. Let's do that deep dive. Let's try to understand. So as you mentioned that we are keeping catalog to keep track, and so business can actually make use of that, and they can understand that which tables is being referenced, what is going on. Let's suppose you heard there are a lot of companies coming in the catalog market, and the main work of catalog, which what is your good name? Rakesh, you explained that it is used for tracking. You heard that there are a lot of companies trying to build a catalog, and they are trying to build a company out of that. If you have to build a startup or build a company or build a project, what more you can do with that particular catalog? Can you think for a moment, and any answer is fine. Like what are the additional things that you can give? You know about AWS Glue, right? What does AWS Glue does? What does the Hive Metastore does? Think about it for a moment and just come up with some of the more additional feature that you can provide. Yeah. Can someone give mic? There was 2 3 mics more, right? So I will be keeping it like this only. I'm not very fan of the PPT.
One use case is for standardization of data sharing the catalog, the data with other sources, whoever can consume. Another part is while
Can you explain it better?
If I have some data in my ecosystem like AWS,
okay,
I wanted to share with Snowflake.
Okay.
I wanted to share my storage right now there is no standard way. Either I need to do ETL job to some remote system.
But let's suppose your catalog is already present. If your catalog is already present, let's suppose you are using high meta stores or AWS Glue, you can always expose, na? I'm talking what more, like whatever the AWS Glue provide, high meta stores provide, we know what they provide, right? You can always give that catalog, and if Snowflake has the capability to connect to your AWS Glue, they can do it now. Like what is the additional things that you are adding on that particular catalog?
Yeah, many of the catalogs right now are owning the managing the Iceberg tables underneath. Like I said,
No, I only want, so I was a big fan of Iceberg, so I was thinking if I have to create a company and create a product out of that, only for Iceberg, because I know Iceberg waves is trending and lot others are trying. If I have to create some different catalogs which can have additional capability than high meta stores and AWS Glue, only for, I'm talking about only for Iceberg. What more I can do?
writer conflict resolutions. Right now there is scan planning. Each engine has to do their own scan planning.
Okay.
The catalogs can do the pruning and most of the scanning in the catalogs itself. They can, each engine doesn't need to understand the internals of Iceberg.
That can be a good point. Like you were saying, instead of relying on the purning methodology of querying engine, like E6 data wants to use E6 data or any Trino or anyone who is trying to use or trying to read the data from the object storage, if catalog can provide the purning on themselves, so any other simple engine can actually connect to your catalog and they can take the benefit of that. Okay, that's a good point. You can have that.
The writers, if there are concurrent writers, right now there is a right now it's optimistic concurrency that Iceberg supports.
Correct.
There is one priority writer and there is maintenance writer. It's not easy for each writer to make some decision, and catalog can make the decision.
Yeah, so that is really good point. If you don't know, Iceberg use CAS methodologies to write. So what will happen if you have multiple writers? Arvind, my lead, I'm working with Arvind. We are actually trying to create a stream ingest applications in Iceberg. Sorry, in E6 data on top of Icebergs and our own algorithms to solve this problem. So Iceberg actually uses something called as CAS. So when you have multiple writer, what will happen? Just think for a moment. Let's suppose you have writer 1 and writer 2 is there. And writer 1 is trying to write data. And both the writer will start, but let's suppose writer 1 completed its work. So writer 2 will be said, oh man, writer 1 has actually done the work. You please take the latest result and then start doing your work. The writer 2 will again start. But writer 3 came into picture at the same time and writer 4, and they are little faster than writer 2. So writer 3 will there do its work, and writer 2 will be like oh, I've completed my work, but it will be like, oh man, you are little late. Writer 3 has actually done his work, and you take the latest output, again go and do your work. So writer 2 will actually be in a very circular loop, and that will actually create a problem when you have multiple concurrency of writing the data in something in Apache Iceberg, because it uses a CAS model, and because of that it can create a problems when you are trying to build a solution like a streaming solutions where you have lot of writer in your place and you wanted to work as fast as possible. How can you do it? So this is a very typical scenario called as commit contentions, which is happening in a lot of the, not only us, many other companies, I think Tableflow, Starburst, all are coming with their own approach to solve this problem and trying to come out of that. So okay, one was like we can have in catalog can provide, technically I don't know, I'm thinking from the product perspective, that okay, catalog can provide their own method, so any other engine coming to them, they can use their own purning, they don't need to write their own purning algorithm. Catalog can provide their own purning algorithm, and then you can use it. Second is like provide some better support for CAS. What more?
Another option can be vended credentials. Like right now, if you wanted to share the data,
I think so. Let's add some other persons also.
Yeah. In such a situation, data catalog will act as a central repository wherein which you can able to store all your metadata, and as well as even you can able to track more data changes, and as well as the
Catalog does
enhancements
the
as
same
such.
thing, not from today, even from database world, catalog used to do the same thing. Even in Iceberg, it is doing the same thing. Like, what is the additional things that we are the catalog? Even if you use AWS Glue or Hive Meta Store, the same thing. What is the work? The catalog will store the same meta data information. No? Like, what is the additional things that we are bringing it here?
So even enhancement of storage and capacity, storage capacity, and as well as
Storage
even
capacity of what? Like your Parquet file or your metadata files? Like where you will enhance the object, like storage capacity?
Okay, in parking as such.
In the object storage.
Yes, yes.
So that comes under the S3. Like even in AWS, if I am a Glue product guy, if I'm trying to product manager for the Glue, it will not come under my web bucket, right? It will come under the bucket of S3, right? S3 team. Same. So I don't think this is according to me, like if I'm thinking just on catalog, I should not think how I'm going to optimize my storage. I'm just a catalog, right?
Yeah.
So
even the computation power will be more, and high power high power computation will happen, and more performance will be drawn out of it as such.
yeah, maybe. But I will like to differentiate it out. Like object is another team and catalog is another team. Yeah. What?
I guess storage is your separate entity, right? You are storing in like S3 or data lake. So catalog may bring in like some of these query optimizations, right? So how do you query this data?
I think the same point, right? The purning algorithms, like you can do little better, so you can make your query faster, right?
Right. So going little bit dive into this, right? So for an example, when you talk about Iceberg, there may be like things like, okay, sorting you can do, right? Apply run length encoding, right, on your data. So again, these are micro optimizations, but then like file of your size. So these are all the tuning patterns, which is again goes into the implementation algorithm. From a catalog point of view, I think how do you query your data and then build a unified layer on top of it?
But even that sorting and all those things, shouldn't it go to querying engine? Why should it come to catalog?
No, it goes to the engine which is managing your data lake, right? Which is managing the how your files are stored, right? Because that comes when you are ingesting data into your data lake. Before that, you may want to kind of lay out your data in a way which is more efficient. Again,
But that again comes to the writer problem. Like if I know my sorting can actually help me as a writer, I will sort my data and write in that person. Yeah, one thing we can say that catalog should be smart enough to at least let us know that if the sorting or JDOT or any other things will actually help, but not like it's a writer problem or reader problem, right? Where does catalogs is?
So yeah, it's on the left. I would say it's on the left hand side where how you're writing the data. Catalog may be, in my opinion, enabling this the multi-engine architecture. Like probably how do you compute or the compute part, right? So again, we use as Athena. Like there may be some other thing, and each tool may bring in their own value, right, based on what kind of data set you have, right, and it may require a different compute paradigm, right? In some cases you may want to load entire file. In some cases you may want to kind of have a different approach, right? Apply some kind of like data aggregation.
Something like a query router where a catalog can be a helper in those type of things where you want to apply some queries on Athena, some on A6 data, some on Databricks, and some on Snowflake.
Correct.
And catalog can be like if a smart catalog can actually help there. Yeah, that I will give you one more things. So do you have some more points or you wanted to say something more?
No, yeah, mostly I think from the right hand side, like the compute engine may be kind of creating an abstraction on top of multiple these compute engine, and then it can kind of optimize your queries also, right? It can use Presto in one case, it can use something else in other cases,
Yeah.
right? So that gives you like as a user, I don't have to worry about what engine I use.
Yeah.
Underneath, it can kind of bring.
We are actually trying to do something like that in E6 data. So yeah, it will take some time, but yeah. So but this is a really very valid point. So let me give you some of my thoughts where I thought catalogs are really, really good. So think about this type of situations. Let's suppose you have to load, don't think about only one Iceberg table. Think about two Iceberg table. And in both the Iceberg table, you want to maintain
the transactions. For what is that? What I'm trying to say that if I'm writing to if I have 2 records or if I have 5 records, it's both the data, like all the 5 records should either go to table 1 or either you should go to table 2. If anything happen in between, you should roll back. All the catalog, most of the catalog, the traditional catalog that we use, Hadoop catalog or Metastores catalog or AWS Glue, they don't support multi-table type of things. Like you can, what does this supports? Let's suppose something happen, they will roll it back. So the dirty data will not be pushed back in only one Iceberg table. But let's suppose you have 2 Iceberg tables, and this is a very classic example. Let's suppose you are having one streaming pipeline which is reading from Kafka, writing to Apache Iceberg table, and you have one DLT table which is another Iceberg table, which is the date later table. And what you wanted to do, you wanted to apply, you wanted to say I will be always, the data will be either written to the main live table or data will be written to the date later table. If something happen, I will always roll back. So let's suppose a catalog can support you multi-table transaction supports. You can do it, right? So a catalog, so lot of new catalog which came into market recently, their major selling point is this, that if you have multiple Iceberg table, I can maintain the transaction supports for you, something like Apache Polaris and Project Nessie, Gravitino. So they are giving this multi-table supports, which is good features according to the product. Again, next thing is think about Project Nessie. Think about a situation. I will give my example. In Walmart, not for every use cases, but I do have access to lot of production things. And let's suppose there is one pipeline which runs in after every 24 hours, and I detected some problem. What is the typical behavior? What I will do, I have to actually revert the data, I have to play the data with that. So the new catalog which came into market, Project Nessie, they give you Git-like experience. What does that mean? Let's suppose you are trying to, you are using 2 branches, main or masters, and second one is I should not say master, I should say main branch and your develop branch. What I will do, my data will lie on the main branch. I will run my experimentations on the develop branch, and I can simply merge my 2 branches, and my data will be reflected. So it's like if I have the Git type of versioning, even with data, where I can actually play my data and my data will not be reflected. So let's suppose it's some BI engineer or data analyst who's actually trying to look into my data and trying to use my data. And if I know something bad has happened, if I am performing some experimentations, I might cause or add some dirty data during my experimentations in the main data itself. But if you have Git type of things, so we all are very much fan of the Git, right? So what does Git helps? So if you listens to the creator of Git, he said why he created Git, because he don't want to talk to the main multiple other person. He want to do his work so other can work independently, and then he was a very introvert type of person. I consider myself a very introvert type of data engineers. When I'm working, I don't want to get pinged by a lot of BI engineer or data analyst. That's my philosophy, right? So what I want to do my experimentation. So if I have something like branching, which a newer emerging catalog like Project Nessie provide, where you can actually have different branch, main branch, develop branch, feature branch, this branch, that branch. You can apply all your changes in one branch, and then you can merge your changes into main branch, and then only the changes will be reflected back. So you will say that, but Ankur, this can be done like this also, na? Like you keep multiple copies of your data at different locations. One will be your prod environment, another will be your GA dev environment, and okay. But as a developer, I don't maintain lot of times all these production environment and dev environment in a different things. And if I'm working with a company like Walmart, what they will, or any big company, in my dev environment, the data volume in the data is not that much up to the mark. So if I want to apply the experimentations, I don't want to load my production data to my dev data, play my experimentations. I can simply write my query using my branching, and I can merge my data. So you can see, so these are the things which has recently came into the picture. Like one example we discussed about multi-table transaction supports, which new catalogs are providing. Another is like Git branching, something like a Git type of working where you can actually do it. So these are some of the product feature that is coming into the market, and that's why new types of catalogs are being developed. Yeah, yeah.
One clarifying question, right? So when you say that there is a branch, is it on the metadata, right? So for an example, I may have like 10 columns in my original data format. I can create a transformation or a kind of addition of a new data. So the branch may have like 12 different columns, right? That may be one scenario. Again, so the question is like, when do you merge these two different stream of your tables, right? So will you keep one copy or two copy of, because for every record you may have two copy of your data. So are we doing like a merging of these two data, like when you merge these two branch? Because from a lineage point of view, metadata can be merged, but the raw data file would be, there would be two copies, right? It is the branches. So
yeah, that is correct. But the good thing about Iceberg, you will always be pointing to one metadata, one snapshot, right?
Right.
So if you, same problem which we discussed in the morning, like if a lot of files are there, you will have to write some compaction job or something you have to do. I think Project Nessie provide you, like you can actually clean, like you can actually clean. I have not experimented, I've just read it, but you can actually apply, while applying the merge command, you can actually apply this thing that it might delete your metadata. I'm not quite sure about it. But yeah, obviously, if you are experimenting on your data, which is actually creating a new Parquet file with you, because under the hood is not nothing fancy is there. You will always have some Parquet file which are immutable in nature. If you apply some transformations and do something, obviously new Parquet file will be created. And so, but the thing is, you can have lot of dangling Parquet file, which you can clean little later. You get some times to experiment on your production data, and the cleaning of the data files, which will be dangling, which is of no use, can be done later. But I think Project Nessie, I think as far as I remember, I don't know if it is released or not released, but they are working in this direction, that using catalog itself, you can fire some commands, and that command can actually at least manage your metadata informations. The data files is still, I don't think they will able to do. They need some writer, some Spark or something which can interact with the Parquet files and try doing it, because that will be huge number of files generated, right?
Yeah, to me, catalog can query different data set at different runtime. So that gives you that capability of, okay, I want to query master versus, okay, dev, or any other data segregation branch, it whatever you have created. But yeah, I guess another question here is like, is there a first class entity that could refer to these the branches, right? Because here either you, like in the Iceberg world, right, you specify snapshot ID or a timestamp, which can you can go back to time to do time table. But from a catalog point of view, is there a first class entity like your Git, right? You have master branch and then dev branch.
By default, it will be always master branch. Even if you don't specify at any at the rate branch, whatever you do, like if you apply snapshot or timestamps, it will always take your master branch. It will never look into your branch, that particular branch. So if you want to apply your timestamps or snapshot or for that particular branch, in the table statement you have to do at the rate and the branch name, and then you can specify your snapshot ID that particular timestamp you wanted to read. So for that, you have to use the branch. Otherwise, by default, it's always the main branch.
So yeah, the question is, branch is supported in the catalog, the branching kind of strategy.
Yeah. It is supported in the catalog. Yeah. But I don't know. I think I've observed this Project Nessie, the open source contributions, they are contributing a lot to Apache Polaris nowadays. I think Dremio is supporting Snowflake things. So I see less contributions to the Project Nessie. But most of my pipeline as a data engineer, I was able to imagine with the Project Nessie. Because if I have something like Git, it helps me a lot of my scenario. So I was able to correlate a lot with Project Nessie. But when I see in the contributions like the open issue, it's not being tracked a lot. I think they are trying to give, it's just my hunch, I don't know, but they are trying to, like all the Dremio contributors, there are a lot open source contributor in Dremio, they are contributing to Apache Polaris and like lot in the recent days. So you never know, I think Apache Polaris might have all the capability in some days about all the Git branching and all those things.
Yeah, actually, I was thinking, always we build a catalog on top of persistent layer. If we could build a data catalog which can land on data on motion or in the flight, like in Kafka topic, that could be the one of the new innovation. For example, data mostly semi-structured or fully structured would be in Kafka as well, right? And that is also, we are keeping their retention for either 10 days or 30 days based on our use cases. So why not I can build a catalog which can directly go and read the data from Kafka topic. I think that was
Catalog never read the data from any topic, na? It's just the pointer where my data is actually there, right?
Correct.
Yeah.
So currently we are reading data from persistent layer, where after Kafka we process and then persist it, and we are cataloging from there, right? If I would be having capability, you're talking about innovation, right? What new, if I would be startup, what I would be building. So that's where I was thinking I would be able to build a catalog which can read directly from the Kafka topic.
But what is the benefit like we will getting from that?
Because nowadays most of the business, they don't want to wait for your processing pipeline need to be completed and then it has to go into your catalog, and from there they would like to read it out.
Let me answer
So,
it. Yeah. So yeah, one thing is that data in Kafka is a stream, right? So it may be continuously coming, right? What you talk about, Flink exactly does that. So you can write SQL-like queries in Flink also, but then it's real time, which is happening as and when your data comes. It generates a real-time output, which can go to another topic or another destination. Whereas the data lake use case is, so if you look at real-time data, you may have like, let's say 100 million events coming in an hour, or maybe like 1 billion events coming in a huge stream, right? But that is real-time being processed, versus a data lake is a data which is there for a long time, and now when you store this data, right, you want to query data last year, what happened last year, or from the last year to now, how many orders I had, or how many events. So that the scale of the data lake would be even very large, right? So you may have like 100 billion events or a trillion event, right, in your data lake. So these two becomes, so querying Kafka would be like a stream processing, which is like a processing your stream at real time, right? And it is effective, but then it should happen real time. Whereas the data lakes also use case of, okay, you have stored the data, you are archiving it just for some use case, and then
so philosophy is totally different, because when I'm innovating in this way, data lake philosophy is going away, right? Definitely. But if I would be having, because from the business side, we have sensed that business need very early data access. That's the I think I was thinking around it, if we could build any connector or any way we can integrate directly from the catalog. If they would like to access live data, stream data, they can give that, okay, within the 5 minutes, whatever land there, can you give me what is there?
I'll actually add a couple of points, right? Your thought process is in the right direction, as in why should I wait for the data to be available? Slight distinction is that we were talking about catalogs, which is actually not the data, but the metadata, right? Which means when I said the thought process in the right direction, we actually don't need to write the metadata to a persistence layer. That's actually a good point. In fact, one of the biggest issues with Iceberg, since it's provide asset guarantees, is you need to pay the price of writing the data onto your disk. Only then it is persistence, only then it is reflected. So when someone queries the catalog, the data should be present in the disk, right? But Iceberg is just a protocol. It's not an engine, it's not an implementation, nothing. At first step, Iceberg is just a protocol. There is also an implementation provided by the Iceberg community, the jar version of it. But then what you can do is you can provide an in-memory version of Iceberg catalog, just that it's not Kafka. Because, see, when it comes to storing data, the first question that you need to ask is what is the access pattern? When it comes to querying catalog, those are not sequential access patterns. It's like a point in time or not point in record access pattern, which means if Kafka is a stream, you cannot go back in Kafka and tell that I want the data present in this point. I mean, you can still access by index, but that's just it, right? You don't have any metadata. So instead of thinking in terms of why can't I have the catalog in Kafka, you can ask the question, why can't I have the catalog in memory, which is a perfectly valid thing. And that's actually a direction that we as a company are going. Because like as Ankur was telling, there is this commit contention where if a lot of writers are writing in parallel, a couple of writers will actually eventually have to keep on waiting because they just don't have enough capacity, right? And a big part of that is because the price that you have to pay for writing in I/O. Instead, what you can do is you can actually write this in memory, which is much, much more faster. But then there's a question of durability. If it's a memory, then what if it goes down? So that's where you periodically flush it to disk. Correct. So the thought process is right, just that it's in memory instead of Kafka. That's how I would put it.
Right, yeah. That idea also sounds good. Because obviously, if I'm asking from Kafka, I'm not looking for very long period retained data. It's on the flight. Right, there are some emergency or issues. Still, we are thinking, okay, it might be, nightly or after 1 hour data has to process. Then we would be able to get what's inside that data. So, in very real scenario nowadays, we are mission critical applications running in, and business wants to see, hey, what immediately happened. So data landed in Kafka, but still it has not been processed. So that's where business.
No, this is totally correct. In fact, like we as a company, by virtue of having a query engine, the reason we are also building an ingestion layer is that we are in a unique position where our query engine can talk to our ingestion engine to get the data even before the data lands in the lake. Why do I need to spend additional 1 minute, 5 minutes for the data to reflect there, right?
Correct.
But it's not so straightforward. Then things like consistency. What happens if you query the data from ingestion layer, but the data never ends up in S3? So all those problems starts to arise. But the thought process is absolutely correct.
Correct, yeah. And another idea, I think we already having most of the catalog. I think Databricks or things are providing. We should be giving capability of natural language way of interacting with catalogs. Yeah.
That is really a valid point. Yeah. And actually, emerging catalogs are actually trying to do that. So I think Lakekeeper or Gravitino, some days back, I was thinking that they are actually providing. They are trying for that. I think Gravitino, they are trying to provide that. Okay, if you ask the questions instead of just giving a table which is being used, if you ask the questions, then they can use the context from the catalog and they can give you the answer. Correct. That is really a valid point. Yeah.
The schema changes are reflecting in the catalog, right? Let's say that is also really a good point. Because it will take times when the next time the crawler runs, then only, let's say, a new file start ingesting into the system, right? That might be having a new column, let's say. And how quickly that column will be.
Integrate with these catalogs, you actually do this consistently with the data change, which means you actually write the data but immediately update the catalog, thereby avoiding this delay.
How frequently that update has to happen.
How faster we can do it.
Correct, that's what.
So I think it takes some time, maybe in AWS Glue. I think he's talking about how fast we can do.
To schedule that crawler.
No, that's what, right? See, it depends upon the approach that you're taking. If you are focusing on writing the data to S3 or Lake first and then updating your catalog, there will be a delay. But that approach can also be done in multiple ways. Either you can have an asynchronous crawler that goes through the data and updates the catalog, or the ingestion system also can actually do this. I think that's what Tableflow also does, where because since they are in part of ingestion, they immediately update the catalog. So you don't even need the crawler in the first place. So I think it's a trade-off depending upon the situation, etc.
Yeah. So every event gets the schema or the lineage, right? So as an event land, you have the metadata around its lineage. So that is the fastest way to do it.
Just how I will get to know that CDC, not data, the schema change, right? How I am going to compare with my base copy versus the new thing that has added into the incoming data.
These catalogs provide transactional guarantees for you where you need to write the underlying data to Lake and then update the catalog, and only if the catalog provides a confirmation that you are aware that data is consistent. If that is not the case, then always there will be a drift between the underlying data schema and the actual schema present in the catalog. So like the ingestion system or the crawler, whoever needs to make sure that it is consistently reflected in the catalog.
Yeah, because my question was like, I need to know my base version of the data, right? Let's say I have 4 columns in my existing set of data. Let's say a 5th column get added into the incoming ingestion layer. So I need to maintain the latest version of that 4 column.
Absolutely.
Metadata, right?
Correct.
Then only I can get to know that a 5th column has added and that is new to my system.
Correct. But then what is the exact question? Like as in?
So how exactly we will get to know that in real time? Let's say I'm getting 2 lakh events per second in my Kafka topic. So each event, let's say if there is a changes in the schema, right, incoming data, so how exactly we can
see? Okay. CDC should be viewed in a slightly different way. CDC is actually, in a way, metadata of a metadata, right? So when you are inserting CDC into Iceberg, in fact, more than normal data, inserting CDC actually results in a lot more contention, at least based on Iceberg, a lot more contention because of the exact fact that you are telling, like schema changes on a much more frequent basis. And I guess that is why, at least this my take is that Iceberg is not designed to be a real-time catalog, and that's where these kind of innovations are happening, where you try to pay the price upfront by doing things in memory, where you can do things much more faster, and then periodically. Iceberg as such is not intended to be a catalog for a real-time ingestion system. You need, like, it's mainly developed for providing a consistent and ACID transactions on top of data lake, right? We are just innovating on top of it by trying to circumvent this, but it's not fully how to put it, like it's not it's not a free lunch. That's how I would put it. Especially in case of high volume streaming, there will be these problems. There are ways that you can, like as I said, one in memory. The other thing, I think, the beauty of Iceberg again is that it's just a specification, which means if you have an in-memory system, you can partition your incoming schema changes based on underlying tables and write it parallelly. Like you don't need to see Iceberg as a single entity where only n number of writers write data. Like you can have business partitions like parallelism within your business domain and write those things in parallel, because you have the guarantee that one table's schema changes will never going to impact the other table schema change. So which means you can have parallelism at a table level. Thereby you get more capacity in terms of writing these records into Icebergs much more faster, right? But these are all, like, how to put it, like specific to the problem that you are solving. So yeah.
Yeah, one
actually,
more.
we can discuss. We are actually out of time. AWS will throw us out of this building after 2 o'clock or something. So yeah, oh, what happened? So we will share this blog that I have written few days back, and I think you got the gist that what emerging catalogs are actually trying to do. On E6 data, if you go and you will search for the blog section, you will be able to find the blogs that we are writing. We are writing very tech-savvy blogs, and that what are the problems that we are seeing in our, while building a querying engine or stream ingest pipeline. And we are a open table format native company, so whatever the problem that we are finding, we are trying to write the blogs on that. So you can follow our blog, and I think we are good to go. Anything more, Freddy? Yeah. Yeah, so yeah, we can discuss during our lunch time. But yeah, thank you everyone for coming. I know this was a very 3 hours of sessions and lot of talks, and that too on Saturday morning and Saturday afternoon. So yeah, thank you for coming, and I hope you have liked it. And if you have some feedback or something, please feel free to give. Yeah, thank you everyone.